Hello and welcome to this video tutorial in which we are going to fly from Madrid Barajas to Ibiza, and we will tackle a VOR DME landing approach. And that was something that many people was asking many times: how can I land using a VOR DME approach? And here I am showing you a bit of the topics we will deal with. And we will deal with walk around, the core and dark starting checklist, taxi to take off, basic use of lights, a lot of different topics that basically will cover how to understand the aircraft, how to understand how to take off, how to understand the charts. We will use the basic charts many pilots use every day. We will use the SID, the standard instrumental departure. We will use the ENROUTE chart. We will use the standard terminal arrival route. We will use the IAC, and that is the instrumental approach chart. We will understand how to calculate the EGT PEAK, and that is how to deal with LEMD mixture in your aircraft, and how to deal about how to enrich the mixture in your aircraft. We will understand many different topics as how to take off, the takeoff checklist, how to follow radials from a VOR, what are the segments in a VOR DME approach, that is the intermediate fix, the final approach fix, the initial approach fix. We will understand all that. We'll understand also how to catalog information, you know, those things that the pilots do when they are talking about Alpha, Bravo, Charlie, about cataloging the information. We will understand how to deal with CRUISE performance tables or CRUISE performance charts. That is very important. And also we will understand how to calculate the EGT PEAK, not only when ascending, also when descending. We will understand many basic topics about the engine. That is, for example, what is the manifold pressure instrument, how to deal with the manifold pressure instrument at different altitudes. We will understand also how to understand the AAC charts, that is how can we find the miss approach point, that is the minimums. That is also a very important topic. And also we will need to understand many different things to proceed with this flight, and we will be dealing with all that here. It is a very long video, as you may know. We are from Spain, but we already know many people follow our videos from the United States and also as well in the rest of the world. So we decided to make an English version of this video to serve all the community. So here we are. And if you find it okay, we start with the video right away. Hi again and welcome to this video tutorial. If you see those videos I am showing you there, part 1 and part 2, those are different videos in which I am dealing with real charts. Okay, I am not using Jepsen charts. I am using the free charts you can find in Spain that are AENA charts. Okay, and you can find in the videos I've showed you how to deal with real charts, how to understand every single step of this flight, understanding every single chart we will be using for this flight. Okay, the videos are in Spanish and the videos cover 2 different topics. The first video, charts. The second video, how to introduce the flight plan in the aircraft. Okay, but even having the videos in Spanish, I always use English subtitle. So I always put in the videos English subtitles, so you can follow them even if you listen to me como hablo español, how do I speak Spanish. Okay, so don't worry for that. You can follow also those videos if you want. And the first thing we are going to do if we want to take a bit of aeronautical culture is to make a walk around, that is a kind of walk in the exterior of the aircraft, to be sure we are not having any problem in the wind, we are not having any problem with the crystal, we are not having any problem in the propeller, we are not having a light that is not working or it is broken, we are not having a problem with something outside. Okay, so real pilots, and I have friends flying airliners 737-800, by the way. So every single pilot, it's the same if you are flying a propeller or if you are flying a big bird. Okay, it's the same. Every single pilot in this world do this walk around. And yes, I know, I realize this is just a simulator, but if you want to take a bit of aeronautical culture, you should do that and follow the checklist. Okay, and if you don't mind, if you want to fly with me, I invite you to enter, please, inside the aircraft, and I'm showing you the combinations of keys you have to press in your keyboard to make that possible, to open the doors, okay, and to enter inside. And as you may know, we are using Lockheed Martin prepared. We have the aircraft completely dead. Okay, so we will start, we will proceed with the cold and dark, and right now I am showing you some basic data for this aircraft. Okay, it is a single piston engine aircraft, the seats it has inside, and we will try to fly in a comfortable flight. We will use rich mixture for this flight, which is the most safe thing to do, and I will explain later on why it's safer to fly and better for the engine, why it's safer to fly with rich mixture. But I am showing you more or less a bit of basic data for this aircraft, and we will be flying very high. Okay, we will have a flight. I will close the door right now, by the way, and if you are so kind, I will please you, will ask you to please you close that door so we can go to visit if you want. Okay, thank you very much. And as I was saying, we will be flying very high, 15,000 feet. Okay, almost the service ceiling for this aircraft. Okay, I am showing you to the right side the checklist we must follow. We already assume I did this checklist, okay, because if I start to read every single thing, we will have a flight of 90 hours. Okay, so I have to summarize a bit, but I am showing you the before starting checklist, so you should take care that your seats are in the correct position, that your seat belts are in the correct position, that you have properly set the parking brake, and that all avionics is off and everything. Okay, so I am also recommending you that you press the pause button for this video, because we are dealing with a lot of different information and I can't speak so fast to explain every single thing. Okay, so pause the video all the time you want to understand every single thing, to follow the checklist and to proceed with the flight little by little. Okay, so I am showing you the cold and dark, and what we are doing right now is moving levers, because just imagine we have a problem with one lever that is broken or we cannot operate it. We don't want that when we start to fly, so we have to check that, and also all the control surfaces for this aircraft. So we have to check the trim, the ailerons, we have to test every single thing, and that is what we are doing right now, testing the control surfaces for this aircraft. We are testing the rudder, we are testing the ailerons, we are testing many different things. Okay, so that is what we are doing right now, and I know this is a simulator, but again, as I said, if you want to follow a bit or to proceed a bit with a bit of aeronautical culture, you should do that. Okay, so we will continue with the cold and dark. Okay, and we will start the aircraft very soon. The mixture must be in the 100%, that is, we must have the red lever push forward, because we need completely rich mixture to start this bird, to start this aircraft. And again, I am showing you the two videos I did that are in Spanish. You can click over them to follow them, but don't worry, because if you listen to me to talk Spanish, I also put English subtitles, so you can follow those videos as well. Okay, we are moving the black lever that is controlling the gas. Okay, because we have to check it it is working. Okay, so we are moving it also. And as you may know, our aircraft is completely dead. By the way, if you click there, you will be able to hide some control surfaces. Okay, we will press the battery right now to have a bit of energy, or to have energy inside the aircraft. If we don't have energy, this won't work. We will press the alternator button. Okay, and the first thing we are going to do, you will see it right now. By the way, if you press A button, you can change, you can switch from different views. Okay, I still moving the black lever, so we are testing it that it is working fine. Okay, and later on I will show you something very nice with the black lever, because if we don't move it a bit, this won't start. Okay, and we are using right now, we are pressing the auxiliary fuel pump for 10 seconds approximately, and the fuel pump, what we'll do is to inject fuel in the engine, because if we don't inject fuel in the engine, this aircraft won't start. Okay, so we need to operate the fuel pump for almost 10 seconds approximately, then we put it off. Okay, because we don't need it anymore. And very important, you have to move a bit the black lever to make possible the fuel entering the engine. If not, this bird won't start. Okay, so you have to do that, and then is when we can press, or we can move the magneto switch and listen to the magic. And listen to the magic is that the engine is starting. Okay, so right now we have the aircraft operating, we have the aircraft properly started. Okay, and if you continue following the calendar checklist, we will deal very soon with the lights. We will understand how to use the lights, but for the moment we will put on the beacon lights. Okay, and I am giving you a view, an exterior view of the aircraft, so you can see the lights in real time operating. Although we have daylight, so perhaps you are not able to see this very well, but well, anyway, I am showing you an exterior view. You cannot blame me for that, perhaps Lockheed Martin. Okay, but I am giving you an exterior view of that. Okay, and we will continue with the lights. Okay, we will, by the way, press the avionics master, because if we don't press that button, our instruments inside the cockpit won't work. We will put on the navigation lights, and we will put on the floodlights. Okay, so we are configuring properly our aircraft to follow the taxi. That we will do that in some moments, and we will start with the GPS. Okay, I am turning it on. I will resize it a bit. Also I am showing you our flight plan, and our flight plan is already loaded to the GPS. For that reason, I was telling you before to follow those videos that I showed you before, because there I was dealing with the real charts. Okay, how to understand that, planning, doing basically a pilot briefing to understand the flight in full, and also how to introduce the flight plan inside Prepare. Okay, which is basically the same or very similar as you may do that in FSX, in Microsoft Flight Simulator X. Okay, you see that wheel there, that button there. If you click below, you will see a plus and a minus sign, and that will help you to navigate through the pages. So in the upper part you have the main pages, and the second part you have the secondary pages. Also you have the reserve frequencies, the active frequencies. We will deal with that very soon, so don't worry very much about that, and I will show you that. Okay, so what we did right now is to tune in the ATIS, the automatic terminal, or the automatic meteorological message that many airports, I don't want to use technical words, the ATIS is a recorded message that airports provide to the pilots, giving different conditions, giving different information like runways in use, like how you have to calibrate the altimeter, which is very important. And we have to calibrate the altimeter in this case to parameter is 29.92, okay? And as you may see, we have that in, by the way, in inches of mercury, and we have it properly calibrated. If we had a different value, we will have to calibrate it to the proper value, okay? It's very important to have in mind that you always need to calibrate the altimeter to make it work properly, okay? That is very important. I don't want to talk very much about this because very soon we will continue taking a look to the checklist, okay? I will put that to avoid the sun hit me in the face. Okay, so I want to emphasize that this is very important. The way that is the calendar checklist that we will follow, and we did step by step all the necessary to make the aircraft start. Okay, we were taking a look to the fuel pump, the magneto, etc. Okay, so I wanted to tell you that it's very important that you calibrate your altimeter always, because you need to have in mind that one thing is altitude, another different thing is elevation, okay? And I will try to explain that very fast. By the way, that gauge I am showing you there is the EGT PEAK, okay? And I am telling you this with the red circle. You can see the red circle, and that is the EGT PEAK, okay, or the EGT gauge instrument, and there you will have to calculate the EGT PEAK. And the EGT PEAK is something you will need to understand if your engine is burning the fuel properly, okay? And one thing that we need to know is that when you start to fly, you have to identify your aircraft in the radar, and to identify the aircraft in the radar you need a squad code, and the squad code are several numbers, 4 digits, that you will have to introduce in that instrument, okay, to identify your flight in the radar, and those numbers will be provided to you by the air traffic controller, okay? So telling you this very fast, I want to tell you again the thing of altitude and elevation, okay? We consider altitude when you are located to the sea level. That is, altitude is always regarding the sea level. So let's imagine in the airport you are going to land is in the shoreline, in the beach, okay? Then your altitude will show 0 feet. Why? Because the airport is at the sea level, in the sea level, okay? You are in the shoreline, the water is touching the runway, so that is 0 feet, because when you have in mind elevation and altitude, in this case altitude, when you have in mind altitude, you must think that it is always regarding the sea level, and elevation is the elevation of the ground. So just imagine the airport is in the top of a mountain, okay? Just imagine we have a mountain of 1,000 feet and the airport is there in the top of the mountain. Then when you land, your altimeter never will show 0 feet. It will show the elevation of the mountain, that is 1,000 feet, okay? That seems to be evident, but it's something very important to know. That is the reason, because you need to calibrate the altimeter, because if you don't calibrate the altimeter, it won't work, okay? And how do I calibrate the altimeter? Well, I can calibrate the altimeter because the air traffic controller will provide me that information. And what happens if I want to follow a real flight with real procedures, so I cannot use the prepared or Microsoft Flight Simulator air traffic controller, because the air traffic controller won't deal with the seat chart, it won't deal with the star chart. How can I gather up the information of altimeter calibration? Well, you have the ATIS, the automatic service, the automatic weather meteorological service. That is a record message. By the way, we have the starting checklist there Okay, we need to put the mixture full reach, the propeller in high RPM, the throttle full open. Okay, we'll continue taking a look to the checklist. I am also giving you a little walk through the GNS 430. Okay, so basically in that wheel you have there, you have a plus and a minus sign in the lower side, and a plus and a plus sign and a minus sign in the upper part. Okay, and the upper part is for the main pages, and the lower side, the lower part is for the secondary pages. And you can take a look to many things like close airports, close NDB, close VOR stations, etc. Okay, if we are taking a look to the starting checklist that we already assume I did this. Okay, we need to have in mind that the throttle must go around 1000 to 1200 RPM. We need to check out the oil pressure, etc. Okay, and I want you to remember, please, the thing of altitude and elevation, because that is very important. You need to calibrate your altimeter. Okay, if not, it won't work. It won't work, and you can get that information through the ATIs. Okay, well, we are inside the cockpit, and the ATIS, of course, to tune an ATIS, you need to put the frequency of the ATIS in the COM navigation radio. And yes, not all airports have an ATIS. Okay, some airports do, other airports don't have an ATIS. Okay, we will start after starting in taxi checklist, and we have to release the brakes. We have to have all the avionics on, and we have to put the lights in our aircraft as required. And you know what? That sadly many people don't know how to deal with the lights, and they don't know how to configure the lights and when they must use this light or that light. And to avoid that, I am giving you a little comprehensive chart in which I am telling you how to use the light. So we will release the parking brakes, and we will start the taxi to go to Ibiza. You know, this magic island in Spain. Okay, so we will apply a little bit of throttle, okay, the black lever, and we will start to move gently, little by little. Okay, and we will fly to Ibiza, magic island. I know many people from the United States, also from Europe, see these videos, and also many people from the Netherlands. Okay, I know that. By the way, I am giving you this chart I was talking about how to use the lights. Okay, and there you have a comprehensive chart or a comprehensive document in which you can consult how to use the strobe lights, how to use the beacon lights, how to use the navigation lights, and I'm giving you it in English on the right side and in Spanish. Si quieres practicar español, if you want to practice Spanish, okay, on the left side. Okay, and I know many people see these videos also from the United States. Florida watch these videos a lot. California see these videos a lot, and I know they even watch my videos in Spanish. So I have to tell you, you have to come to Ibiza, because that place is absolutely magic. It's wonderful, really. It's amazing. Okay, it's like you're Hawaii. Okay, something like that, but in Spain. And we have all the tendencies there of music, of electronic music, and everything. So it's very nice. And the water there is beautiful, really beautiful. You can consult pictures in internet. It's amazing. Okay, and I'm giving you how to use the lights there, and you have also how to use the navigation lights, the taxi lights, and the landing lights, and when you have to turn the lights off, and when you have to turn the lights on. Okay, so I won't read you that chart because you can consult it little by little. Okay, and I will repeat this chart along this flight. Okay, but I am giving you this information there. By the way, what do you see there? We have an aircraft that is going to take off. we have an aircraft that is going to take off. We will take a look to it. Beautiful. Okay, we have that there. Okay, normally I should stop the taxi, okay, but I wanted to share with you the view, okay, the site. Okay, in front of us, by the way, we have the Iberia La Muñoza. Okay, Iberia La Muñoza is a very interesting place because if you don't know that, we have an award-winning company that is Iberia. That is the well, nowadays everything is global. Okay, globalization is a global phenomenon. Okay, there are many companies merge and do things like that. So Iberia was our national company, was our national airline company, that it had a fusion with British Airways. So basically, I don't know very well how is the thing about this, but I know, I think that they are a part of British Airways. Okay, but in front of us you have the buildings from Iberia. So in front of us we have the Iberia hangars. Okay, I don't like to say hangars because for me that is like a kind of GM laboratory. Okay, they receive a lot of engines every single year to analyze them, to do the proper maintenance. They receive around 250 engines a year. Okay, and they are dismantled piece by piece, part by part. Okay, they have a non-destructive test area in which they do a lot of tests, okay, to analyze every single part of the engine. I'm showing you several pictures there, okay, and that is fascinating. I know they invite people to take a look to the installations, to the facilities sometimes, okay, but it's amazing. Okay, those are Iberia airplanes with the old logo, the old livery. Okay, and for that reason I was parked there because I wanted to give you a little walk close to La Muñoza. Okay, I'm giving you that information in English there so you can take a look, and remember that we have a lot of technical information in this video, so the pause button is your friend. Okay, so please use it. Press the pause button every time you need to read text, okay, because the video has a length, okay, and I have to explain a lot of things, and sometimes I don't have physical time, let's say, to read every single text I have on the screen. Okay, so please use the pause button when you need it. Okay, we are doing the taxi. Okay, we have a very Spanish name from Sevilla, by the way, from Seville, Virgen Macarena, which is a very typical religious sculpture. Okay, very typical. So we wanted to use a Spanish name for aircraft. Many aircraft from Iberia use a Spanish name. Okay, I will show you right now the standard instrumental departure chart. Okay, sadly I cannot use Jepsen chart. I admit they are the best charts in the world. They are of course from the United States of America, of course, but I cannot use them. I cannot use those charts due to copyright reasons. So I cannot use that, but we have very nice charts in Spain. Our equivalent to Jepsen in Spain is AENA, which is a company that provides you this information for free. By the way, we don't have to pay for that, and I am showing you the departure we will use in our standard instrumental departure chart, and exactly we will use that road you see there, and that is NANDO ONE ECHO. Okay, NANDO ONE ECHO, and I will enter in further details later on. Okay, little by little when we are taking off, and when we will be flying. Okay, I will be showing you every single step we have to do to follow that departure, and there you have a little indication there, and the abbreviated procedures, let's say, that you have to follow for the NANDO ONE ECHO departure, and on the right side you have it in English. Okay, so we will have to tune the VOR DME frequency from Madrid Barajas. There you have the frequency. Then in the horizontal situation indicator instrument, we will have to select course 125 with the OBS that is selecting the radial 125 from the Madrid Barajas VOR DME, which frequency is 116.45. Then we will take off from the runway 14L with heading 129, and the autopilot on using our navigation we will send to 4,800 feet. Then we will select in the GPS the nearest board page to control the distances to the board. That will be the equivalent to the DME equipment. And when reaching 10 nautical miles from the Madrid Barajas VOR DME, we will continue doing more things. Okay, I want to stop here because we have to cross a runway, and it is risky. Okay, in fact, long time ago we had a fatal accident in Madrid Barajas in 1983, I think it was, and two airliners collide because an airliner was trying to cross a runway and the other airliner was trying to take off. So you can imagine the explosion. Boom. Okay, two aircrafts colliding on the ground. So I will stop here, and I will remind you that when we cross this, of course we need to have authorization for the air traffic controller, but we cannot use the air traffic controller here because we are using procedures very close to the real life. So the air traffic controller of the prepare simulator is not so smart. Okay, so we need to do our own rules, and I am assuming the air traffic controller gave me permission to cross the runway, and when crossing the runway we do it for today, not for tomorrow. That means that we need to accelerate the beat. Okay, it's not something that you have to cross it to admire the landscape. Okay, so we have to go a bit fast. Okay, we continue with the taxi, and don't worry for the NANDO ONE ECHO departure, because the NANDO ONE ECHO departure will be commented little by little, every single step of it, and when we will be flying you will see that it's not so complicated. Okay, so we will continue with the before takeoff checklist. Okay, if you are my co-pilot, please, I will kindly ask you to follow the checklist and to remember me something I could forget. Okay, so we need to have the seat belts correctly, the parking brake set before the takeoff, before to take off, the radios check, the engine instruments check, the flight instruments check and set. Also the throttle, we will have to check the throttle at to 1700 RPM. The propeller, we will need to exercise the propeller to obtain 304 or 400 RPM to check it, etc. Okay, and very important, the point 10 and the trim set. Okay, we'll talk about that, but before we talk about that, I want to talk to you about the anemometer and the arcs. Okay, we have the white arc, and what tell us the white arc? Okay, those are the extended flat operating speed, okay, or the speeds in which your aircraft can use flaps. Then we have the green arc. Those are the normal operation speeds. So those are the speeds in which we can fly without extended flaps. Okay, that is the green arc is in which we will follow our enroute chart, basically the most part of the chart of the most part of our flight. And the green arc is an arc in which it's not very suitable to fly there, because if we have turbulence, if we have turbulent air, we can cross the red line, and if we cross the red line we will have a problem. Okay, because we could have a structural damage, and that could be that a wing could go away. Okay, we don't want that, because if you lose a wing or the crystal of the cockpit or something like that, we will have a severe problem. when flying. So we don't want never to cross the red line, because the engineers that designed this beautiful J-wheel, which is the Bonanza I-36, okay, I really love this plane, and I know many real pilots love it. Okay, it's a classic. It was designed, if I don't remember bad, in 1947, and still being modern. It's beautiful. In the 21st century, it's beautiful, and it was designed in 1947. So basically what we have changed here is the interior equipment, okay, the avionics, but the rest is the same, still the same, still being beautiful. It's amazing. Okay, so we'll be talking also about the anemometer, and also about the TAS speed arc, the true speed. Okay, and very important is that you need to have in mind that as long as the aircraft increases its altitude, the air density is lower. As the air is less dense and altitude increase, the aircraft tends to fly faster. Okay, so 140 knots is not the same on the ground that if you fly in a high altitude. So for that reason we need the true airspeed, okay, because the aircraft tends to fly faster when it is to higher, when it is in higher altitudes. Okay, well, in physics you can understand what is fluid dynamics. Okay, if you want to understand what is fluid dynamics, you can take a look to it in Wikipedia, for example. Okay, to understand a bit of it. Okay, but anyway, summarizing this, what it's telling you there is that we consider the air as a fluid. Okay, and its properties change according to the altitude. Okay, and also the behavior of your aircraft changes as well. Okay, I am showing you because your aircraft is flying inside the fluid. Okay, okay, I'm showing you the La Muñoza hangars. Okay, los hangares de Iberia hangars. Okay, and that red aircraft, it's our aircraft. Okay, and that is the taxi we'll be doing. Okay, to access the runway to take off. Okay, so basically we are going very close, and also I want to show you here what is the term coordinator. Okay, the term coordinator is a very simple instrument. It's a very easy to understand instrument. Okay, the goal here, I'm giving you all the technical explanation in both languages, in Spanish and in English. Okay, you can read both. You can switch, if you are bored to read in English, you can switch to Spanish if you prefer. But the goal here is to maintain always the ball center when you are in flight. Okay, doing the taxi, it's the same. The goal here is to maintain, of course, doing the taxi you cannot do that, but when you're flying in flight, you must maintain the ball center. And how could you do that? Well, you can do that moving gently your aircraft. Okay, don't try to imitate Tom Cruise when he was flying in Top Gun. Okay, this is not Top Gun, and we are not Tom Cruise. Okay, so we need to do a board flight. Yes, I will repeat that, a board flight. Okay, because it will be a safe flight. Okay, so our idea is always to maintain the ball center. Okay, the term coordinator is very important. Okay, and it is also the slip indicator. Okay, and for a comfortable flight in the air, the goal is to maintain the ball center when turning left or right. Turning left or right moderately will help to this point. Okay, so please don't try to imitate Top Gun when flying the Bonanza. Okay, we are not Tom Cruise in the movie. And that is the term coordinator. Okay, and there I'm giving you all the information in English to understand it. Okay, we will be departing very soon from the runway 14L. Okay, and of course in the red circle I am indicating you that instrument. Okay, the term coordinator, and that I am indicating you right now is the manifold pressure. The manifold pressure is a very interesting instrument. Okay, I am showing you there an animation, okay, about how a piston engine works. Okay, with the times. the combustion has. Okay, I will show you also this information in English. But the manifold pressure is an instrument that shows the difference between the air pressure of vacuum inside the intake manifold and the relative atmospheric pressure of the air around the engine. And to make this easy, we need to understand that the goal here is to maintain the needle into the comfortable zone or the green arc of this instrument. And there, I'm giving you a visual reference that you must have in mind when flying this aircraft. That reference is having the aircraft centered to the runway or to the taxiway. Okay, that is the reference, because every pilot in the world take a reference in the same way. When you're driving a car, you have your own points of reference to park it, to drive it, and so on. So there you have a reference for it, for this aircraft. Being centered to the runway is that, maintaining the line there. That is the variometer, or the vertical speed indicator, and the vertical speed indicator is absolutely vital to tackle a VOR DME approach. And why? Because you can program, or you can follow descent rates. Okay, and when flying the aircraft is very important, because sometimes you will need to ascend to a certain vertical speed, and sometimes you will need to descend to some to a certain vertical speed. That will be the vertical component of the aircraft, and when the aircraft moves to the left or to the right, that will be the horizontal component. Okay, and that is this is very important, because this instrument is fundamental to tackle a VOR DME approach, allowing the pilot to calculate the descent rate from the FAF, which is the final approach fix indicated in the instrumental approach chart to the runway. Okay, so we will basically, a VOR DME approach is that you will reach to a point called final approach fix, and there you will have to program your autopilot at descent rate, and the variometer will help us to this point, because we'll be able to take a look to our descent rate. Okay, we'll try to dim the cockpit interior lights before taking off, because in that way we will accustom our eyes to have lower light conditions in case we have an accident. For that reason, the aircrafts reduce the lights inside. Sorry, and we have there the altimeter. Okay, the altimeter, as I told you before, need to be calibrated. Okay, so you have to calibrate the altimeter to make it work properly, and we will need that information that will be provided by the air traffic controller, or yes, when you tune the ATIS frequency, okay, which is an automatic weather service provided by the airports, and it will give you the altimeter calibration to make it work nice. Okay, so we continue with the taxi to the runway to take off, and also we will have a lot of time to take a look to the departure procedure. We will follow the standard instrumental departure chart, then we will connect with the enroute chart. Okay, then we will connect also with the start chart, which is the arrival chart, and finally we will use the instrumental approach chart, IAC chart, to follow the proper descent rate, to follow the proper radial, and to tackle a VOR DME approach as we should. Okay, so taking a look again to the before takeoff checklist. Okay, very important. We will have to use or set up the trim properly. Okay, and that is that the elevator trim must be set to 3 degrees or 6 degrees nose up if only front seats are occupied. Okay, and we'll have also to have our flaps properly configured, that is flaps up. Okay, doors and windows must be secure and closed. We'll have to check out the flight controls again. We'll need to put the full mixture we'll need to the mixture be full rich, okay, and I will enter in further details about this later on, okay, about when we talk about combustion analysis, intake manifold, air pressure, inches of mercury for the pressure manifold instrument, etc. okay. And well, basically for that people that is starting to fly and don't know what is a flap is what you see there in that picture, okay, and will help us to reduce the speed of our aircraft, okay. So aircrafts need flaps to reduce our speed, okay. And a very important thing that we need to have in mind is that when we use flaps, normally the nose of our aircraft tends to rise, okay, and we correct that behavior with the trim. That is very important, okay. So when you are going to land and you apply flaps, normally the speed of your aircraft will decrease and the nose will rise up, okay. And we need to correct that behavior by using the trim, okay. That is very important because many people don't know very well how to do this. And flaps, as you can read there, are devices used to alter the lift characteristic of a wing and are mounted on the trailing edge of the wings. And the idea is that we reduce the speed, okay. And I tell you the same here. Tip: when flaps are applied, aircraft speed is reduced and the aircraft nose tends to rise. To correct this, you can use the trim tab, okay. The elevator trim, we need to put down a bit the elevator trim, okay, and that is something that you will understand how to use it with practice, okay. When you practice it a lot, you will understand how to use the trim properly. What will happen is when you apply flaps, your nose, the nose of, well, not your nose, of course, the nose of your aircraft will rise up, okay, and your nose too, by the way, and you will have to use the trim tab. And what will happen is that you will maintain the reduced speed, okay, but also the inclination of the aircraft will be the correct one to descend, okay. That is something that you need to understand when flying, okay. And you will see that because we will be using the trim tab also to land in Ibiza, okay. And we continue doing the taxi. We are very close. I am showing you also the airport chart, okay. I gave you the details of this chart before, if you have seen it, and we are very close to takeoff, and we will start to take off very soon. And when we take off, we will be following the NANDO ONE ECHO departure step by step, and don't worry because I will be with you telling you step by step how we need to, what we need to do, and how we will be following the chart, okay, to proceed with this particular departure, okay, because the standard instrument, by the way, we have traffic on the rear side, and this particular chart, okay, this particular chart, the standard instrument on departure, have several departures, okay, several departures according the runway you want to take off, and the runway will take off. We will use a particular departure, and that is the NANDO ONE ECHO departure, okay. I thought that departure was nice and easy to understand, so I wanted to use it. And we are very close to the runway, and very soon we will take off, okay. We have almost 1 hour of video just doing the takeoff, the cold and dark, all the things little by little to start with this, okay. And I am showing you there, by the way, a picture of the trim tab, okay, and the trim surfaces in your aircraft, okay. So you can take a look to it because we have several trims, okay. Not also the elevator trim. We have also a rudder trim, okay. So we have several trims in our aircraft. I'm giving you a detailed picture, let's say, to allow you to see the trim surfaces in our aircraft and the role they play when flying, okay. I will give you also the English text very soon, don't worry, so it will switch to English. I normally put the English text in yellow, okay, so you will be able to follow these tests. And there we have the trim tab, or the aileron trim tab, or the elevator trim tab. And as I tell you there, trim tabs are small surfaces connected to the trailing edge of a larger control surface on a boat or aircraft, used to control the trim of the controls. For example, to counter hydro or aerodynamic forces and stabilize the boat or aircraft in a particular desired altitude without the need for the operator to constantly apply a control force, okay? And that is what I told you before, because when you apply flaps, what happens with your nose and also with the nose of your aircraft, that tends to rise. And in that particular case, what you will need to do, you will need to push forward the control surfaces of your aircraft, your steering wheel, let's say, to make the aircraft reduce the nose, to make the aircraft the aircraft nose go down. But if we use the trim tab, we can automatize this task, okay? So the aircraft will put the nose automatically, or not automatically, but in a constant way, looking down, okay? Okay, so we will be configuring the aircraft very soon to take off. I am giving you also again a little walk through the ENS 430, and there I am showing you we have tuned we need to tune, okay, the Barajas VOR DME. VOR is the same that VOR, okay? VOR is the same as a VOR, okay? It's the only difference is the technology, eh? This is a Doppler VOR, okay? But it's basically the same. So there we have tuned the frequency of the Madrid Barajas VOR, okay? And we have it in the active frequency. Now it is in the reset frequency, and you need to observe the changes we have there in the horizontal situation indicator instrument, and the yellow line is the course director indicator, okay? When that line is broken, we won't reach a radial, and when that line is complete, we will reach a radial from the VOR, okay? And that that button is the course director indicator, and when we press it and we switch to VLOC mode is when we will be flying radials, okay? So that is very important. If you switch that button to GPS mode, you will be following your flight plan. When you switch it to VLOC mode is when you will be flying radials, okay? Very important. And we will use do an extensive use of this very soon, because we will take off very soon. And that thing you have there is the OBS, omnidirectional bearing selector, and it will help us to select our course, and that is to select our radial, okay? So we will need to select the radial 125 from the Bravo Romeo Alpha VRA. We don't say that, we say Bravo Romeo Alpha. We use the NATO phonetic alphabet, okay? Because when we are spelling things in the air, the radios could fail, or the sound could be a bit noisy, and we need to spell the things very well. So we say Bravo Romeo Alpha. And we have selected the radial 125 from the Bravo Romeo Alpha VOR, that is the Barajas VOR, but also we need to follow first the course 129, okay? So we need to take off with on navigation following the course 129, and for that reason we are using the HD, the heading hole selector, okay? And select here the RAM 129, okay? So our heading will be 129. So summarizing, we will take off with heading 129, and then we will be following the radial from a certain radial from the Madrid Barajas VOR. We will be selecting our desired altitude, that will be 4,800 feet, and we will press also the Alt button, okay? We will press also the HDG button to be sure we are maintaining our on course, that will be 129 degrees, okay? The flight director button is already activated. It's very important. Our autopilot won't work if you don't have activated the flight director. And following again the before takeoff checklist, we will check out our steering wheel, the pedals also, and that all control surfaces are working properly, okay? We will check out that. okay, the rudder, the ailerons, the elevator. We will be checking all that because we don't want to have any problem when taking off. Okay, taking off is a very risky situation, and if we have an emergency situation, perhaps if we are taking off, we should handle that in flight and descend again, or because when you are taking off, it's a very risky situation. So our seat belts are okay. I'm showing you again the GNS. Remember that we have tuned the VOR from Madrid Barajas, and we have it in the active frequency. Okay, later on we will take a look to the GPS, to the EGT gauge, and of course we have to take a look to the fuel tanks. You know that we have enough fuel. Okay, aviation gas, which is the fuel that this aircraft eat. Okay, we can eat hamburgers if you want, or pizzas, but this eat something different. Eat aviation gas. Okay, so we have enough food in the tanks. Okay, or aviation gas. So we need to check out the fuel tanks and also the air pressure. We were taking a look to the oil pressure, and we will be taking off very soon. Of course, we need to be sure our doors are closed, and also the crystal there is closed. Okay, to be sure everything is fine, and we will be moving very soon to access the runway and taking off. And when taking off, I won't put this aircraft on the number in the runway because we need as much length possible, okay, to take off. We don't want we have a problem in which we are running faster, okay, and we don't have enough length in the runway. So also the aileron trim must be neutral, that is to 0, okay, and we need to have it in 0 position. And very soon we will configure the trim, the elevator trim, to the 3 position or 6 position, okay, and that is basically what I am showing you there, how to configure the elevator trim. Okay, so the elevator trim must be configured to 3 degrees or to 6 degrees if only front seats are occupied. Okay, I will configure it with 3 degrees. I feel comfortable with that setup. Okay, and I assume I am flying this aircraft alone. Okay, observe you have D's and U's. Okay, U, D. Okay, that is U up, D down. Okay, and 0 positions. So we have 0 that will be neutral. Okay, and then we have, if we go up, U up, if we go down, D down, and we will select 3 up. Okay, so I select 3 and not 6 because I'm flying this aircraft alone. Okay, I assume I am flying this alone, so I will select 3 and I feel comfortable with that setup. Okay, so I'm testing also flaps. Okay, I'm the checklist. Don't tell me if I don't remember, but don't tell me to check out flaps, but I prefer to go beyond and also check flaps because I don't want to have any problem later on. And also again, I'm giving you the chart in which I'm showing you, I'm also testing the rudder. I'm giving you again the chart in which I'm telling you how to use the taxi lights, the strobe lights, the navigation lights, how to use all the lights in an aircraft, because we will have to configure again the lights before to take off. And later on we will take a look to the manifold pressure instrument, okay, and that mysterious thing of inches of mercury. Why inches of mercury? Okay, I will show you that also later on. And there we have the takeoff speed and the landing approach speed. For the takeoff we will need around 70 knots. Okay, so when we will be close to 70 knots, or not close, but when we reach 78 knots or 70 knots, we will move the steering wheel a bit back, okay, the steering wheel or the yoke, okay, and the aircraft will just take off. Okay, we will move it gently. okay, and we will take off. Okay, I will activate the panel lights, okay, because I want to have a better light conditions inside the aircraft, okay, and we will go little by little configuring the lights to take off, okay. I will activate also the strobe lights, okay, and I gave you before the charts indicating you how to use the lights properly, okay. And very soon we will be departing. Or if you press the A button, you can switch to different views in prepare. That is the outside temperature. We will use that later on to control to understand and to use the cruise performance tables, okay. That's very important, okay. And we have probably configured the lights, okay, as you may see that, okay. And very soon we will take off because we have basically everything configured. We were taking a look before about the proper use of lights in an aircraft. That's very important because many people fly an aircraft and don't know how to configure the lights, and they don't know if they must activate the strobe or not, or when they need to put the landing lights. And by the way, we will configure right now. We'll activate the landing lights. Talking about that, we will activate the landing lights, okay, right now, and we will start very soon. We will very soon proceed with the takeoff. If you press the A button in prepared, you can switch from different views. We have our flight director activated. Again, we will select 4,800 feet, and we have the altitude hold button activated, and also the out navigation button, HDG button activated. And remember, we have already activated the VOR from Madrid Barajas frequency in the active frequency. We have already loaded in the instrument the radial 125 from the Madrid Barajas VOR, and also we have selected our in the holding hold selector the ramp we will follow when we take off, and that is 129, okay. So we will follow we will take off with ramp 129, and then when reaching a certain distance from the Barajas VOR, we will follow the radial 125, okay, and we will do that step by step following the standard instrumental departure chart, and I will explain you that little by little. Okay, adverse yaw, okay, it is a phenomenon that happens especially in propellers single engine aircraft due to turbulent airflow from the propeller, which impact over the aircraft fuselage and move it to the right side or to the left side. That means your joystick in 90% of the cases works fine, okay, because many people enter in forums to ask why the aircraft is going to the right side or to the left side, okay. My joystick is not properly configured. Well, your joystick is properly configured, but when you take off, you need to have in mind that the aircraft will move to the right side or to the left side, okay, and that is a natural effect that occurs due to the adverse yaw, okay. So we need to correct that with the rudder. Okay, we have there the takeoff checklist. So we will put full throttle to 2,700 RPM. We will need to put the mixture in full reach, and well, the before checklist is very basic. It's a very basic checklist, okay. And again, I am showing you what we will do right now. We will depart with the ramp 129 in out navigation with ramp 129, and we will reach a distance of 10 nautical miles from the Madrid Barajas VOR, okay. I am exercising a bit the engine to know our engine is working properly, and we will take off very soon. So we are ready to go. I will do the call outs. Parking brakes release. We have the parking brakes activated, and we release that, and we apply full throttle, and we start to take off. So starting to take off, and it is very important that you put your eyes in a point in the horizon, okay, and you try to maintain to hold that point, and when you reach 70 knots, move the steering wheel back gently and we will be flying. Okay, it's as simple as that. Okay, it's very natural. Okay, so gear up, we don't need the gear anymore because it also will compromise our speed. We have a positive climb, that is, we are flying. Okay, and right now we will press the Alt button, but we'll need to we will activate the autopilot, but remember that when you activate the Alt button, okay, you will need to reprogram the altitude. So we put 4,800 feet. Again, we have the climb checklist. Okay, and there we have the NANDO ONE ECHO departure, and what we will be doing right now is to follow the nearest board page to know our distance to the Madrid Barajas VOR. Okay, and remember, nav frequencies are to fly and CAM frequencies are to talk. So if you need to talk with the air traffic controller, your frequency is a CAM frequency. If you need to follow radials, follow an ILS approach and stuff like that, your frequency is a nav frequency. Remember that, okay? Because many people don't know the basic role of frequencies. And when you have the frequencies of a VOR, if you want to know if you are reaching the signal of that VOR, remember that VORs have an identification code, a Morse code. So if you press that button, nav1 button there, the audio nav1 button, we can listen the Morse code, okay, and that practically will tell us that we have reaching the VOR signal. And if we are reaching the VOR signals, we can work with it, okay, so we can follow its radials and things like that, okay. For that reason we need the audio button, because we also can listen if we reach that station, and also the identification of that station. Of course you need to know a bit of Morse code, that is a very basic identification, are just 3 letters, in this case Bravo, Romeo, Alpha, okay. And there you have the nearest board page, so we will take in a look to it very close to make sure we reach 10 nautical miles, because the chart is telling that we have to take off with RAM 129 and to follow 10 nautical and to reach a point in which we will be far away 10 nautical miles from the VOR, from the Barajas VOR, and at that point also we need to have 4,800 feet. That is very important. So basically we are following right now with real procedures, and we are following the standard instrumental departure. Also we are checking out our instrument. Our manifold pressure value is 20, that is very normal, okay. We are ascending. We need to check out also the air pressure and also our RPM, okay, and of course the fuel tanks are nice, okay. I will link a bit the mixture to calculate the EGT PEAK, okay. There is a very nice document I want you to read that is about the combustion analysis, and that document is from Alcor Precision Aviation Products. It's a very nice document that tells you what is the EGT PEAK, but the goal is that in that gauge you see there that put EGT, the goal is that you move the red lever forward or backward until you put that needle in its higher position, okay. So that is the goal of calculating the EGT PEAK, put that needle in the higher position. But remember, that is only a reference point, okay, because later on you will need to drop a bit the peak to make the combustion a bit cold, but you can do that doing the combustion a bit cold in a rich side of the peak or in a lean side of the peak, okay. And don't worry about that. I understand that perhaps you don't understand anything about this, but don't worry, because we will be talking very soon about this, okay. So I want you to concentrate, to focus please on our takeoff and the NANDO ONE ECHO departure, and remember we are following 129 ROM, and we will be reaching 10 nautical miles from the Barajas VOR DME, and at that point we will be at 4,800 feet. That is what the NANDO ONE ECHO departure is telling us. So we're taking a look very close to the Barajas VOR And as you can see, we are right now to 10 nautical miles. Okay, so we proceed right now to follow the Barajas VOR radial. Exactly, we did that segment that you see in the circle. We traveled with RAM 129, and then we reached 10 nautical miles after 10 nautical miles from the Barajas VOR. At that particular point, we were at 4,800 feet, and then what we are doing right now is following the net altitude that you see there. So we will be flying right now. To 7,200 feet, and as you can see, we have pressed the nav button, and that is because right now we are not following the ramp 129. What we are doing right now is following the radial 125 from the Barajas VOR. And remember that when we end the segment of the Barajas VOR, we will connect with other VOR, and that is the Perales VOR. Okay, I know you will spell this in a different way, especially if you are in the United States. Okay, but listen to it in Spanish, Perales. Okay, and we will follow the radial 108. Okay. And something very interesting I want to show you is the experiment of the candle in the dish with water and the glass. Okay, if you burn a candle and you put a glass over it, and you have a dish with water, what happens is the water rise. Do you know why? Well, this is very simple, because the air pressure inside the glass is lower than the air pressure outside, and what happened is the exterior air pressure push the liquid, push the water inside. Okay, for that reason we need to use the red lever to enrich the mixture or to lean the mixture. And what happened is when we are ascending, due the air pressure decrease and therefore the air density decrease, that means that we have less oxygen in the air, and consequently, if we have less oxygen in the air, we need to put more air inside the engine to make the fuel burn better. Okay, that is very important. So just imagine you have a very beautiful Ferrari or Lamborghini, okay, and you are in a very high mountain. Well, what will happen is that the car performance will be reduced. Okay, because the altitude will reduce the performance. Okay, I am following right now an ascent rate. Okay, and because I want to be sure we follow what is indicated in the segment, we have been taking a look in the standard instrument departure chart. What I told the autopilot is that it ascends faster. Okay, so I have programmed the autopilot with an ascent rate of 900 feet. Okay, because right now we are following what you see there in that red line. Okay, we are following the radial 125, and we need to be to reach that particular point. That is that we need to reach a point in which we be at 22 nautical miles from the Barajas VOR, and at that particular point we need to reach an altitude of 7,200 feet. Okay, and how do we know we reach that point? We know that because we are consulting all the time the nearest board page in our GPS. Okay, and when we see that the Barajas VOR is showing us the value 22, okay, then we will know evidently that we are 22 miles away from the Barajas VOR, and at that particular point, okay, we need to reach that altitude, that is 7,200 feet. And again, I am showing you the red line, which is indicating the ramp or the course we are following, because right now we are following a course, not a ramp. Okay, a course, because we are following a radial. Okay, and I prefer that when we follow radials we say course, and when we follow a certain ramp we say hidden. Okay, I prefer that to avoid to mix concepts in the brain. Okay, so what we are doing right now is that following the radial 125, and we need to reach that point, 22 nautical miles from the Barajas VOR, and at that particular point we need to reach 7,200 feet. And because we have reached that point right now, we continue with the next segment of the departure, and that is that we still continue with the radial 125, but we need to send a bit more. And that, in this particular case, what the NANDO ONE ECHO departure is telling us is that we need to ascend to 9,300 feet, and we need to reach a distance of 33 nautical miles from the Barajas VOR. And because I want to be sure the aircraft is ascending with the proper rate, I am telling the aircraft that ascend with a bit of more happiness. Okay, so I am telling the aircraft to take an ascent rate of 900 feet or 1,000 feet. I don't remember that, but well, you can see that in the autopilot. Okay, because I'm taking a look at many instruments at the same time I'm talking with you, so sometimes it's very difficult to have in mind every single detail. Okay, well, the next thing we will do is to organize, okay, the flight, and we will follow, when we reach that point, 53 nautical miles from the Barajas VOR, and we must our altitude at that point must be 9,300 feet. When we reach that point, automatically we will switch to all different radial to other different VOR, and that is, we will follow the radial 108 from the Papa Delta Tango, PDT, Papa Delta Tango. We use the NATO phonetic alphabet, and that radial from the VOR, from the Perales VOR, that it's a nickname, if you want to say, okay, it's Papa Delta Tango, okay, and it's identification, not nickname, of course, but if you prefer nickname, but no, it's identification. Its identification is Papa Delta Tango. So when we reach that point from the Barajas VOR, 23 nautical miles, 9,300 feet, okay, from the radial 125 of the Barajas VOR, we will switch to other different VOR, and that is that we will switch to the Perales VOR, which identification is Papa Delta Tango. You can see it there. So right now what we need to do is to take a close look to the Bravo Romeo Alpha BRA, Bravo Romeo Alpha VOR, because we need that value. I'm showing you there, indicate 33. Okay, I will reduce a bit the power, a bit, not the power, well, I will reduce a bit the RPM. Okay, I will talk later about this, but I want to reduce a bit the RPM because I don't want the engine to suffer so much. Okay, so I want to limit a bit the RPM to make also I am in the normal operating speed, green arc. Okay, I don't want also the aircraft be very accelerated. Okay, and I am comfortable with the speed I'm having. And right now my altimeter is showing, or our altimeter, because you are with me, so our altimeter is showing 9,300 feet, 9,308 or 9,307. Okay, 9,300. Okay, so our altimeter is showing that value. Okay, and right now what we will do is very soon we will select a different course. Okay, because we will need to follow the radial 108 from the Perales VOR, and very soon we will reach the distance that the NANDO ONE ECHO departure in our standard instrumental departure chart, standard instrumental departure is requiring. The standard instrumental departure, exactly the NANDO ONE ECHO departure, is telling us that in the particular segment we are flying right now, that when we reach 33 nautical miles from the Barajas VOR, we need to switch to a different VOR and to a different radial. So take a look there, because we are very close to the end of the segment, and right now we'll switch to the other frequency. As you can see, the changes you have seen with the broken line there in the course director indicator. This is the yellow radial, and right now what we did is to select a different radial, the radial 108 from the Papa Delta Tango VOR. This is the Perales VOR, and we press the navigation button to make sure our aircraft is following the radial 108 from the Perales VOR. Okay, so basically we are doing exactly what the departure chart is telling us, and you can see the second circle. We have reached the Bravo Romeo Alpha point there that I am showing you with an X, and right now we are following what the animated arrow is telling you, that we are following the radial 108 from the Papa Delta Tango VOR to reach a particular point that is called NANDO. Okay, so we will reach NANDO, and when we reach NANDO we can connect with our enroute chart. Okay, an enroute chart is like if you purchase a map from the United States or Canada or the United Kingdom, okay, to have all the roads in all the country. Okay, it's basically like that. It's a GN map. Okay, and we are having an enroute for our country, in this case Spain. We will take a closer look to the exterior temperature. By the way, when you see a black triangle, it says that it is a compulsory notification point. That is that you have to to contact the ATC, and when the triangle is white, is that you are reaching an airway, but you are not forced to contact the ATC. Okay, so when you see a black triangle, it is a compulsory notification point. Okay, and there, in people in the United States would see when they see the temperature in Fahrenheit, they feel very comfortable. But you know that in Spain, and if you don't know, I tell you this, that in Spain we use Celsius. So for us, it's not very nice to see the temperatures in Celsius, because we don't know very much the equivalency in Fahrenheit in Celsius. We think naturally in Celsius and not in Fahrenheit. So you will see more happy taking a look to the temperature, to exterior temperature, and this in Fahrenheit. And the exterior temperature will be extremely important, because with those temperatures we will be able to know the performance of an engine, or to calculate the proper speeds for an engine. Okay, with the CRUISE performance charts. But don't worry about that, because we will take a close look to those charts very, very soon. And right now, what I am showing you in that red box, okay, is our distance to the Papa Delta Tango VOR, which is the Perales VOR. Okay, as you may know, we are flying with the in VLOC mode. Okay, we have of course the autopilot connected. The flight director is also connected, because the autopilot don't work. It doesn't work if you don't have the flight director on, and navigation must be on to follow the radials. Of course, the GPS must be in VLOC mode, and of course you need to press the button Alt to hold your altitude, or the altitude you program. Okay, so right now I'm showing you again the use of lights, and right now it's time to turn off the strobe lights. Okay, and there you have the cases in when you have to turn off the strobe lights. Okay, when exceeding the active runway, in flight, in cloudy weather conditions. We have some clouds, so I am turning off the strobe lights. Okay, again I'm telling you also, right side English, left side Spanish. Okay, the proper use, or the use you need to use, the use the way you have to use the lights. Okay. Okay, so we are inside. We are 9,300 feet. We don't have any turbulence at the moment, so this is a very quiet flight. And we continue taking a look to the Papa Delta Tango VOR, exactly to the nearest board page, because we need to know we are reaching a certain point. And to be sure we are reaching the Papa Delta Tango VOR, if you press that button, do you listen that? Okay, that is the Morse code, the identification code of the VOR. So in fact, we are having the signal, and right now we are following the radial 108, and our goal right now is to reach NANDO, which is at 56.3 nautical miles. Okay, and that is our goal. Okay, so basically you are listening right now the Morse code identification of the station of the Perales VOR VOR DME station, which is identification is called Papa Delta Tango. You are listening to it, and of course we are following properly radio 108 from that station, and our goal is to reach a certain point that is called NANDO, and it is at a distance of that VOR of 56.3 nautical miles, or 56.3 nautical miles. Okay, so if you press A, you will be able to switch from different views inside the cockpit, and if you want an exterior view, you must press S. Many people flying flight simulator knows already these keys. Okay, and when you have an exterior view, if you again press A, the A key, you will be able to switch again from different views. Okay, so basically that is the same that you had in Flight Simulator, in Microsoft Flight Simulator. And take a look to this. Take a look to this. Just imagine you're in the United States and you're extremely millionaire. Okay, and you have a collection of Ferraris, and you have a collection of Lamborghinis, and you have a collection of cars. Okay, why don't you purchase a Beechcraft Bonanza? It is amazing. You will never have the sights inside a Ferrari. This is amazing. Okay, for the price of a Rolls Royce, I will be able to have my own Bonanza, to do my own flights, even to pay the training, and even I save money. So you can have a lot of things, and this flight, by the way, is not very expensive. As you may realize, this aircraft don't eat Big Macs. Okay, it eats something different, and it is called aviation gas. Okay, and I don't know, because I think you in the United States have lower prices for the gas than in Europe, but more or less I think that, by the way, if you take a look to the speeds, we are in the normal operation speeds. Okay, we are in a very comfortable speed. We are not reaching the career speed wide arc there. And more or less, this flight will cost us 450 euros. Sorry, I don't tell you this in dollars, but you can use an online converter or converter to calculate. 4,500 euros, for 500 euros more or less, is what this flight will cost us in real life. Okay, and right now I'm telling you in real life. Okay, and of course, if you take a look again to the AGT gauge, we will again adjust our mixture to find the AGT peak, because we are ascending, so our goal is to move the red lever until we put that needle in its higher position. And right now you don't see this right now because you don't have a view of the full cockpit, but right now what I will do is to move a bit forward the red lever, but just in such a way the AGT peak drops in 20 degrees, because in our cruise performance tables we need to fly regarding the AGT peak, which is a reference 20 degrees reach or 20 degrees length. Okay, and that will make the difference in which we can decide if we are flying with rich mixture mode, let's say, or lean mixture mode. And take care, if you are short of money, like I am many times, and you want to fly lean, take care, because if you decide always lean, you can severely damage your engine and also the exhaust pipes. Because they can change its color to white, and even they can be rotten in long time. So the safest thing will be to fly with rich mixture. It's better for the engine cooling, it's better for the engine performance. And well, I know this is a simulator, but if you want to fly the simulator as you should fly a real aircraft, it's better that you pay more money but you fly safer. Okay, so it is always recommended to fly rich enrich mode, let's say. Okay, so we will take a look to the Papa Delta Tango VOR, you see there, and our distance to the VOR, you have this, which in Spanish is distancia, and in English is distance. Sometimes Spanish and English is not so different for several words. Okay, so we have the distance there, and we have a distance of 45 nautical miles, or 45 nautical miles. I will switch off, if you allow me, the audio button for the identification of the VOR. And right now, I want you to listen the ATIs from the Barajas airport that we reach also, and the signal here. And remember that you have information alpha, okay? And what is that thing of information alpha? Information power, information chart. What is the thing, that mysterious thing? Okay, something very important that you need to have in mind is that when you're flying, these meteorological devices are telling different messages along the day, and because the weather conditions change along the day. And also the active runways change along the day, they need to organize, they need to catalog the information in several codes, okay? That is Alpha, Bravo, Charlie. It is using A, B, C, D. It is using the alphabet letters, okay? But because you're flying, you need to use the not phonetic alphabet. So you won't say A, you won't say B, you won't say C. You will say Alpha, Bravo, Charlie, etc. for A, B, C, etc. Okay? So basically, a weather an automatic service for weather information like the ATIS start in the early hours of the morning to broadcast information with the code alpha. Then if we have a variation in the weather condition or active runways or other conditions for a particular airport, then it will switch to information Bravo. And if we have again other change, for example rain or a change in the active runways, it will change again to information Charlie, and so on. Okay, that is what happened. So for that reason, it is very important to catalog the information, because when you contact the air traffic controller, you will tell the information, the kind of information you have. Because imagine the active runways change along the day, and you think that for example the 33 left runway is the proper runway to land, and imagine 20 minutes before that runway have changed, and now it's not the active runway to land anymore. What could happen? What could happen is when you land, other aircraft is taking off, and boom, explosion in the middle of the air, great and terrible sadness everyone. Okay, so we don't want that, and because we don't want that, we need safe. And to have safe, it is extremely important, I repeat that, it is extremely important to catalog the information, okay? So for that reason, pilots use these codes, okay? As you may know, we are flying in the with VLOC because we are following radials in this case from the Papa Delta Tango VOR, which is the Barajas VOR. We have there in the VLOG, in the navigation radius, we have the frequency for the Perales VOR. We have the frequency there, okay, as you may see it, and you can basically see that, okay, and we are flying in VLOG mode. And that is the way in which pilots, talking again about the information that the ATIS released, that is the way the pilots catalog the information, okay, with natural phonetic letters. Okay, I am showing you the NANDO ONE ECHO departure that we are following, and as you may know, we are following radial 108 Papa Delta Tango VOR, which is the Perales VOR, and our goal is to reach a certain point, which is, you see that in yellow, and also put your circle, to follow the radial 108 and to reach a point in which we be at a distance from the VOR of 56.3 nautical miles. And we are very close to that point, and right now, yes, right now we need to switch it to GPS mode. So we will change our course director indicator to follow the enroute. okay, our enroute chart. And I'm sorry, but I have to stop the flight. And I want to talk with you about combustion analysis, about engines, about fuel, about air, because if not, this flight won't be safe. And because safe is our priority, I have to talk a bit with you, have a conversation with you about engines, okay? So if you allow me, I want to talk with you about cruise performances tables. And when you are flying, you have this kind of tables, mysterious tables with strange numbers there, things like secret codes of something. And you have length, you have reach, 20 degrees of peak EGT, and values of the manifold pressure in inches of mercury. For God's sake, what is this? Okay, this is very simple to understand. It's not complicated at all. Okay, so but to understand these charts, before we need to take a look, to pay attention a bit about engine performances. Okay, so the first thing I want to talk with you is about combustion analysis. And I want you to understand a very nice instrument that is called the manifold pressure instrument. Okay, the manifold pressure. This instrument is telling us a value in inches of mercury, and as you can see there, we have a green arc. The green arc is the comfortable zone. So the goal, of course, when you're reducing a lot the power, you won't have the needle inside the green arc. But when you're flying, the goal is to maintain always the needle inside the comfortable zone. And the comfortable zone is the green arc you see there. For that reason, you see arcs. This is not like Picasso, you know, this is not art. And those color codes have a reasoning, and they have a why, okay? They have a why, a reason they are there. So what we need to do is to put the needle there, but the manifold pressure instrument is telling us the power we are using in our engine. Okay, so we need to understand that we have several aircraft, and this is very important. We have aircraft from variable pitch and fixed pitch. Okay, for example, the gas entering the engine is the amount of mixture of air and fuel to make the combustion in an aircraft with variable pitch, the Bonanza A36, for example, planes with 3 levers, black gas, blue RPM, and red mixture. The revolution of the aircraft are controlled by the pitch, blue lever, and that is why we have the gauge called manifold pressure, because unlike fixed pitch propellers, aircraft such as the Cessna, in this aircraft of fixed pitch propeller, we don't have 3 levers, we only have 2. Black gas and red mixture. In fixed pitch aircraft, on the contrary to the variable pitch aircraft, we do not have a blue lever to control the RPM. Therefore, in this aircraft of fixed pitch, as soon as you apply more gas, black lever, the aircraft shows more RPM. In variable pitch aircraft, it's not like this. In this aircraft, we already have a lever, the blue lever, to control the RPM. The manifold pressure gauge shows pressures of the manifold. This gives you a value in inches of mercury, and what tells this indicator is the amount of mixture, A fuel, we are getting into the engine. Giving more gas to the aircraft by moving forward, the black lever will result in having a higher value in the manifold pressure gauge. Hence, more manifold pressure, when we have more value in the manifold pressure, represent more inches of mercury and more gas, and consequently more power. Okay, so that is the mystery of the manifold pressure. And there we have an animation I am showing you with a piston engine. Okay, and we are using a piston engine because the Bonanza A36 is a piston aircraft. To understand this in an easy way, and remember that the pause button in the video is your friend, please press the pause button all the time you need to read the text, okay? But what happened here is that you need to imagine your aircraft like a fish in a tank, okay? We have water there, and that is a fluid. And you will say, well, I don't have water, I am flying. Yes, the air is also a fluid, okay? You can read about fluid dynamics in Wikipedia. So you are in a fluid that is called air. And what happened? What happened is that when you get altitude, when you rise, when you ascend, the air density, as we said a lot of times, the air density is lower. And you know what happened? That we have here different fluids. We have the fuel, the aviation gas, which is a liquid, is a fluid, and also we have the air, which is a different fluid. And you know what happened? What happened is, because the air density is lower, what happened is the mixture is enriched by default as soon as you ascend, because these changes in pressure do not affect to the fuel. And for that reason, we can say that the mixture is enriched automatically as soon as you are ascending, okay? But what you need to understand is that when you are ascending, to summarize this and to make this easy, when you're ascending, we need to lean the mixture. We need to put more air to make the engine burn better the chicken inside the oven, okay? To make the engine burn better the fuel inside, okay, we need to put more quantity of air inside the engine. That will make we fly in an ecologic way, also because we won't produce a lot of contaminant waste, and also to know what proportion of air and fuel we need to use, we need to calculate the EGT peak, okay? We will talk a lot about the EGT peak, but the idea of this is measuring the exhaust pipes gases to know the temperature they have, and to know they are burning, they are in the maximum point, in the higher point of heat, to understand or to know that our engine is burning the fuel as it should, okay? Because when we have the exhaust pipe temperature, the gases of the exhaust pipes reach a high temperature, or the highest temperature, we know that we have the right proportion of fuel and air, okay? So the idea with all this is that you reduce the red lever, back until we move the needle of the EGT peak in its higher position, okay? And then we proceed to move a bit forward or backward or rearward, again the red lever, to make the peak drop a bit, okay? And how much is the drop? Okay, what is indicated in the CRUISE performance tables, and the CRUISE performance tables is telling you 20 degrees, so you will have to drop it 20 degrees. Okay, let's do a practical case, okay? Let's find the EGT peak right now, okay? Right now we are flying to a certain altitude, and we will move rearward, that is, we are leaning the mixture to find the EGT peak. See how the needle rise. Okay, we have the EGT peak in this case. We have the peak in 623 degrees, okay? That is the higher position. So the goal is moving the red lever rearward until the EGT will be at its highest position. But this is only a reference, okay? When we find the peak, we will need to enrich or lean, okay? But anyway, if you lose the peak at any time, you will need to move the red lever, forward or rearward until you find the peak again. And you know what happened? That when you move rearward the red lever and the needle gets its higher position, it's the same. If you move the red lever forward or the red lever rearward, the peak will drop. The peak will drop, always will drop, okay? So when we reach the peak, to decide if we fly lean or rich, we will reduce the temperature from the peak in the degrees indicated in the CRUISE performance table, and that is 20 degrees. So remember that once we obtain the EGT peak, is the same we will move the red lever forward or rearward, the temperature will drop as well. So the difference between moving the red lever forward is that we put more fuel, rich, and rearward is that we put less fuel, lean. That is the difference. And what we need to find is the peak, and then reducing the temperature from the peak in the number of degrees indicated in the CRUISE performance tables, in this case 20 degrees from the peak. Remember that, or again in the peak, okay? Hence, we need to find the peak and then reducing the temperature from the peak in the number of degrees indicated in the CRUISE performance table. In this case, as we said, 20 degrees. And that is exactly what means flying 20 degrees rich or 20 degrees lean from, remember, the peak. which is what we see in the cruise performance tables, okay? Of course, you won't do that exactly, okay? More or less approximately 25 degrees, 30 degrees, 19 degrees, more or less that, okay? But that is the idea. It's not absolutely necessary the mixture be extremely accurate with total mathematic precision, okay? More or less, more or less. Don't worry for that, okay? But that is the idea. And in that way, right now, you know, or you should know, how to understand the cruise performance tables, okay? I will enrich the mixture a lot because I will put right now again the red lever forward, and we will calculate again the EGT PEAK, okay? I like to emphasize this a lot, okay? So take a look to the cruise performance tables. That cruise performance tables is showing us 20 degrees lean of peak EGT. Remember, see that, of peak EGT. And what we are doing right now, we are moving rearward the red lever or forward until we get the EGT needle get its higher position. We have it in its higher position, okay? And now we reach that reference point, because the EGT PEAK is only a reference point. Then we decide if we fly lean reach. Now we have moved a bit rearward the red lever, so that is that we will fly economic and we will fly lean, okay? I'm giving you there a text showing you the consequences of being short of money always and flying lean, okay? The technical consequences for your aircraft and for its technical maintenance. So it's always better to fly rich, okay? Rich is always better. It's always better. But anyway, the best thing is to fly rich, okay? Yeah, I'm sure you agree with me about that, that rich is always better. But the thing is that you need to fly rich, okay? Because in that way, yeah, it will be safer for your aircraft, okay? So calculating the EGT PEAK and flying 20 degrees lean or 20 degrees reach from the peak or of the peak is not so complicated. It's as simple as moving the red lever rearward or forward until you put that needle in its higher position, and then making the temperature drop a bit from that particular peak by moving forward or rearward the red lever, and then making the temperature drop what is indicated in degrees in the cruise performance tables, okay? We have seen that in a practical way, and I am showing you a big view of the instrument, because taking a look to the instruments, little goggles and stuff like that is sometimes a bit complicated, okay? Because in real life you will have a better information, more accessible, because you have the gauge in the real life. You will be able to take a look close to them and all like that, okay? So the simulator perhaps it's not so, the quality of the information you receive is not so beautiful, and you will have it in real life, okay? Anyway, I am showing you the instrument there. Right now it has at a peak of 606 degrees, and remember one thing, okay? Remember one thing, and the EGT PEAK is not always in a certain temperature. It will change according to your altitude. Perhaps in 5,000 feet you will have a peak in 520 degrees, and perhaps in 10,000 feet you will have a peak in 630 degrees, okay? It's not always the same value. That value changes according your altitude, okay? According your altitude. So basically that is what you need to understand about the peak. And the best thing is what I told you, is to fly always rich, because when we reach the peak and we move forward or rearward the red level, we're establishing that we are flying rich or lean regarding the peak. And the goal here is to make the temperature drop from the peak the quantity of degrees indicated on the cruise performance table, and we have two options to make that temperature drop. The option 1, flying rich. then moving slightly forward the red lever. Or when you reach the peak, you have other option, flying link, not so safe and better for the worst for the technical maintenance of your aircraft. Then when reaching the peak, move a bit rearward the red level and make the temperature drop in the quantity of degrees indicated in the cruise performance table. Okay, and that is basically all you need to know. Well, not all you need to know, because we have to deal also with altitudes, exterior temperature, and also a value in inches of mercury. That we have that information in the chart to decide what kind of chart we use, and to get information to retrieve information from the chart, and that is the recommended speed. And I want to emphasize this: recommended speeds. Okay, you are not obligated to follow those speeds. Okay, so basically, if you fly rich, you will get you won't get light speed. So if you were thinking to get light speed and go to Mars in 1 second or immediately, I don't know what time, you won't do that. Okay, I won't do the calculations right now to fly into light speeds to go to Mars. What I'm telling you is that you will get only 2 or 5 additional knots when flying rich. But the good thing of flying rich is that your flight will be safer. Okay, it's like a sporty driving, let's say. And lean, you will save money, and perhaps you will have more range and nautical miles. So when you have to decide if you fly rich or lean, I will say that you need to fly rich always, except if you have certain conditions, certain meteorological conditions in which you see you are short of fuel, and perhaps you are not very safe, you are not very sure, sorry, about the quantity of fuel you have, or you have a technical problem in a fuel tank and you're losing power, and you're losing fuel, and you need more nautical miles. You need to extend your operational range, and then in that case you have to make sure to get more extra nautical miles when you're flying. So finally it will be you will be the one that will decide if you want to fly lean or want to fly rich. But what is recommended? To fly rich always, because it's better for the engine cooling, it's better for your safety, it's better always for the engine maintenance, and the fuel consumption also won't drain you. It will rise slightly, something, so it won't be extremely expensive. Okay, so it is recommended always to fly rich. Always. So basically, when you reach the EGT point, the EGT peak, remember that that is a reference point that you put the needle in its higher position and then fly rich. Okay, and then in the performances we have a value in inches of mercury. Okay, inches of mercury is like if we decide the speed we want to drive in a road. Okay, in the United States we will use miles per hour. We use kilometers hour here in Europe. But well, as soon you apply more gas, as soon you apply more fuel, the faster your airplane will fly, and more speed knots you will get. So also you will get a higher value in the manifold pressure. Okay, and basically when you reduce the speed, you will get a lower value in the manifold pressure. So what cruise performance table should I use? Okay, the cruise performance table that is close to the manifold pressure value. Okay, and I am showing you here a different thing. See that red mark, please, and see also the altimeter. You know what happened? That the value of the manifold pressure instrument will decrease as long as you descend. Okay, because the air pressure is the air pressure is decreasing, and that means that the manifold pressure instrument is also the indication of the manifold pressure instrument is also decreasing as soon you are ascending. So even if you have the black lever to the maximum, what will happen is the manifold pressure value will decrease. So as long as the altitude increase, the air pressure decrease. That means your manifold pressure value decrease as long as you increase your altitude, even if the gas black lever is always in the same position. Let's imagine you're flying with black lever full at 1000 feet. Later on, you fly the same with black lever full at 2 different altitude, let's say 10,000 feet. If so, you will get always different instrument values for the manifold pressure gauge. Therefore, at different altitudes, to maintain a certain engine power, we will need different values in the manifold pressure instrument. Once you are in the air, you take a look to the manifold pressure gauge and pick the cruise performance table that best complies with the value of the instrument, be 21, 23, or 25. So, if you are flying 22, with a value of 22 in the manifold pressure gauge, you will have to use the chart of 23 inches of mercury, because it is until 23, until 21, until 25, okay? Because it's very difficult, you always get the same value. So you are flying to 22 or 24 inches of mercury, the value is telling you 24, you get the cruise performance table that is indicating you the value of 25, because it's always until that number, okay? As you may know, when you move the red lever forward, we enrich. When you are moving the red lever backward, we are leaning. And when we are leaning is because we are very high, and because we are very high or we are ascending, we need more air because the air have less oxygen. And you know what happened? That if we don't have oxygen, the fuel don't burn well. We need more oxygen. And because when we are getting altitude, the air have less oxygen, things don't burn so well. That is the reason we need to put more air and less fuel, because we need to burn that fuel better. And to burn that fuel better, we need more air, okay? So if you're using some matches to burn something, perhaps on the ground, you will use just one match, and in a very high altitude you need all the box of matches, okay? Because the air doesn't have soap quality, the soap is not so good, don't have so nice things inside, okay? So this is important, and I promise you that I will stop the speech soon, okay? But it's very important to know how to fly Racer, how to fly Lean, because many people, when they are flying simulators, don't know how to understand the instruments inside the cockpit and how to understand the information, the valuable information these instruments are giving you, okay? So the most important thing, remember, to summarize this, you need, when you are ascending, by the way, when you are close to the runway, you need always high RPM and mixture in full range, that is the red lever absolutely forward, okay? Why? Because we need that our engine speed don't be limit in RPM. Let's imagine you have a problem when you are descending, and you have a problem that perhaps you don't have nice visibility, and you have to avoid to land, okay? In that particular moment, you will need to proceed with other maneuver, and you will need to have there all the maximum power you can grab to your engine, okay? For that reason, we need at lower altitudes, we need high RPM, the maximum RPM or high RPM, and the mixture in full range, okay? But the thing of the AT PEAK is very simple to understand, okay? You move the red lever backward or rearward until you get the middle of the AT gauge in its higher position. And when you do that, you have two options. Option number one. But remember, getting the AT PEAK is not enough. I repeat that. Getting the AT PEAK is not enough. That is only a reference point, okay? And when you get that reference point, you have to decide if you fly reach, or you have to decide if you fly limit. And when you reach the AT PEAK, that is that the needle in the AT gauge is in its higher position because you were moving rearward or forward the red lever. Then at that particular moment, you will have two options. Option one, move a bit, slightly a bit, the red lever forward, and the temperature will drop from the peak. it's the same if you move the red lever forward or rearward. When you get the peak, it's the same if you move the red lever forward or rearward. The temperature always will drop. Always will drop. Always. So when you get the peak, decide if you want to fly rich or lean. You want to fly rich? Okay, move the red lever slightly forward and make the temperature drop the number of degrees. If in this case are 20 degrees, then 20 degrees. Make the temperature drop from the peak 20 degrees, but moving the red lever forward. Okay, forward. In that case, we will be flying rich. And we will be making the temperature to drop what is indicated in the cruise performance table. And to fly lean, we do exactly the same, but on the contrary, okay, you will get the peak, and when you get the peak and you get the EGT needle in its higher position, you will move the red lever slightly rearward, okay, to make the temperature drop the number of degrees that is indicated in the cruise performance tables, that in this cases are 20 degrees from the peak of the peak. Okay, so then you will be flying in lean mode. Okay, so that is the thing of flying rich or flying lean, and of course, as I said a lot of times before, flying rich is better. Okay, as you may see, it's not very complicated to fly rich or lean. This thing is very interesting to know. Of course, you can get all the information telling you there by reading the text you have in the screen. Press the pause button all the time you need, move the video, rewind the video again to see all this information, to read it, come with a coffee or a tea or whatever you like. Okay, but the most important thing here is that you understand this basic engine settings to make the engine works properly. Okay, because if not, we won't do a safe flight, and of course our engine won't grab the needed performance to make it work fine. Okay, so that is very important, and because we already know this information, this safety information, we can back again to the flight, if you allow me. So we're following the ENROUTE chart, okay, and we continue with the flight plan. Okay, we're using the ENROUTE lower airspeed chart. Okay, and remember that we need to have activated the yaw damper, okay, the autopilot, and I am giving you there, I won't read you that information, okay, you read that, but I am giving you the information about the yaw damper and what is doing the yaw damper in the aircraft. Okay, I am only showing you how you need to have configured the autopilot on, flight director on, navigation on, because in this case we are following the ENROUTE because the cruise director indicator is in the GPS mode and not in the VLOG mode. Okay, I am showing you right now the point, the airway we will be reaching, and we are going to Motil. Okay, on the right side you have the in English our flight plan, but as you may see on the left side I am putting a circle, okay, with the airway we are reaching, and our cruise checklist is very simple. We need to have the cold flaps closed, the power set, and the mixture set. So we have already that, and remember that because we are ascending, because we are flying very high, we are almost close to the service ceiling for this aircraft that is 16,000 feet. We are flying to 15,000 feet because I wanted to have a beautiful sight, okay, from Spain. So I am given this almost to the maximum, so we are flying to 15,000 feet. Remember that our speed is also decreasing, okay, and we have to take care with that. Okay, so I will give you some bases later on to control that, and I am showing you an animation there. So our aircraft is departing from NANDO and it is going to Motil, okay, which is also a compulsory notification point. Remember, black triangle. When we have a black triangle, we have to contact the ATC. Okay, so it is a compulsory notification point. And now, if you allow me, I want to relax a bit because I don't have enough air to breathe because I don't stop to talk. And I need to do a kind of zen relaxation right now. and I want to rest a bit because I am very tired. Okay, take a look to the GPS. The GPS is there. Okay, we are following the flight plan. Our flight plan is not showing the airways names, okay, because I did not edit the names when introducing the flight plan in our aircraft. But well, anyway, we are following waypoint 1, waypoint 2, waypoint 3, okay, and the magenta line is the indication of a flight plan. So we need to get the magenta line, and when we get the magenta line, we will follow the magenta line, and we will say we're inside our flight plan, okay, and we'll be following the flight plan. And that thing, remember that we are going from Madrid Barajas to waypoint 1, which will be the first point of our flight plan. And right now the behavior of the flight director or the cruise director indicator will change. In this case, the arrow is broken because we have not reached yet our flight plan. But when we reach our flight plan, the yellow line will be complete, okay? And right now I will reduce a bit or ascend. In this case, you can ascend, you can put more or less feet per minute. I will indicate more feet per minute because next airway, when we reach next airway, I want to be sure I am exactly at 15,000 feet, okay? And I also put you several eyes there to tell you the gauge you need to monitor to take care and be sure you're safest flight, okay? Because when you're ascending, your airspeed will decrease, okay? Will decrease. And something very important when you are ascending, you have to activate the pitot heat, and also the propeller heat, because we don't want to have ice in the pitot tube. If we have ice in the pitot tube, we can have a severe problem. It's a fatal accident, and we don't want that, okay? If we have time, we will talk about that later on. But at this time, I'm showing you the sights we have there, and you will agree with me that this is better than a Ferrari, okay? Because in a Ferrari, you won't get those beautiful sights. They're so high, and you have so much peace there. It's amazing because the sight you have there is beautiful. It's you, your aircraft, the landscape, and everything is for you. So you have total relaxation, total peace. This is better than yoga, this is better than Zen, this is better than any fundamental thing you want to put inside your brain. Okay, it is amazing. And remember the name of our aircraft, Virgen Macarena, which is a very famous sculpture, religious sculpture in Seville, south of Spain. I invite you to come to Seville, which is a very magic city and a very nice place to go, exactly in Easter. And if you come to Seville, remember to come in Easter. You won't forget it, okay? Okay, you see some clouds there, okay? And the clouds we are having there very nice. Well, I did I programmed the weather conditions in Prepare, because sadly Prepare doesn't allow you to use real-time weather, okay? That is a kind of little quarrel I have with in Lockheed Martin forums because I one day introduced that feature that we already had in Flight Simulator. By the way, I am disconnected the vertical speed for the autopilot because I see that our airspeed is decreasing a bit dangerously. So I will tell the aircraft to ascend, but not so fast, okay? And I will tell the autopilot to continue ascending, but not so fast, okay? That will make I control better the air speed that I am getting, the value I am getting in the anemometer, okay? And just imagine how high we are flying and how peacefully is a flight there, okay? So we are very soon, we are going again to calculate the EGT PEAK with all the theory I told you before, by moving the red lever forward rearward until we get anything in its higher position, and then making the temperature to drop in 20 degrees, which is what it is indicated in the CRUISE performance tables, to decide if we fly reach a lane. We have reached the EGT PEAK, and then I will move the red lever slightly forward, okay, to make we fly reach, okay? And there you have the site. The site we have is beautiful and amazing, okay? Absolutely total peace there. We can relax a bit, if you allow me to, and we can take a look to the beautiful sight we have there. By the way, this is not a long flight at 3 hours, but for our propeller it's very nice. And remember what I told you. Remember what I told you. Right now I will switch off the landing lights because we won't need them anymore. Remember the chart or the table in which I showed you how to use the lights. And that thing that is centering, you know what it is? That is the horizontal component. And that is telling you our aircraft is getting aligned with the path of our flight plan. Okay, that is what it's telling you, the horizontal component. Also, when you are getting a radial from a VOR, you will get also the horizontal component centered, because you will be reaching that particular radial. Remember that the CDI button, the cruise director indicator button, can be following the GPS, or it can be following the VLOC mode. When it follows the VLOC mode, it is following radials, and when it is in the GPS mode, it is following the flight plan. And in both cases, the yellow arrow, if it is broken, that means we have not reached the radial, or we have not reached our flight plan. And when the broken arrow, the broken yellow arrow, be complete, then we can say we have reached a certain radial or our flight plan. In this case, because we are flying in GPS mode, we are following our flight plan and not a radial, because to reach a radial we need to fly in VLOC mode, and of course to have the VOR station properly tuned in the radio, in the navigation 1 radio. Okay, that is very important. So we have the site there, and we are not very far away from Ibiza. In fact, you will see the sea very soon, but you will see the sea very soon, and the approach to Ibiza is magic. I wanted to proceed with a VOR DME approach, because many people don't know how to do that, and they are asking all the time about how to proceed with a VOR DME approach. And I want you to do that also following real tables, because there are many basic concepts people don't understand about how to proceed with a VOR DME approach. And to proceed with a VOR DME approach, you need things like to understand what are the basic segments to follow an approach. Okay, see again the yellow arrow. Okay, do you see the yellow arrow? Do you see the behavior of the course director indicator? See how the aircraft is getting centered with the path of our flight plan, and see how the yellow arrow is being complete. That means we are reaching our flight plan, because we are flying in GPS mode. But if we were flying in VLOC mode, and we were having selected a VOR radial, what could happen is, when the yellow arrow is centered and not broken, is that we are reaching that particular radial. Okay, so I am showing you that the CDA button can have two positions: GPS to follow our flight plan, or a VLOC to follow our radials from a VOR. And that the behavior of the yellow arrow is to get always complete and not broken. Okay, let's take a look to the exterior temperature. We have a lot of cold there, 7 Fahrenheit, and we have an altitude of 5,000 feet. Remember, altitude regarding what? Regarding the sea level. Okay, it's not elevation, and many people confuse this: elevation, altitude, elevation, altitude, altitude, elevation, elevation, altitude, altitude, elevation. Okay, and they confuse that. Altitude regarding the sea level. Okay, elevation, what the ground elevates you. Okay, simple as that. I am in a mountain, so I have an elevation of, let's say, 1,000 feet. Okay, I am flying an aircraft, and my altitude is showing 15,000 feet. So that is not regarding the mountain, that is regarding the sea level. Okay, so simple as that. So when we are flying, we need to monitor our gauge. Okay, and what I told you before about the manifold pressure gauge, that as soon as we ascend, we get a lower value. because the air density is lower. Anyway, I will reduce a bit the propeller control, the RPM, okay, and I will put this to the 75% more or less, because I want the engine to be more rested to when working, okay. And we are doing a comfortable flight. Remember that in the cruise performance tables you have recommended power settings, but are recommended power settings. It's not compulsory you follow those settings. I mean, you don't have to exceed those settings, okay. You only have to get those values or go below those values. And the next airway we are reaching, we are very close to it, 4 nautical miles, as you see there in our flight plan, is Motil, okay. That is the next airway we are getting, and when we reach Motil we will move to other different airway as it is indicated on flight plan, okay. Because I did 2 different videos showing also how to introduce the flight plan inside the simulator, and also how to organize the flight, and understand the charts that we are using in the flight, okay. Both videos are around 7 hours or 6 hours, something, I don't remember. It's a kind of pilot briefing, and as I told you before, when we started this video, is that those videos are in Spanish, but don't worry, because even if they are in Spanish you can follow them, because I always put English subtitles. So don't worry for that, because if you don't understand anything at all of what I am saying, don't pay attention to that, just read the subtitles, because I put subtitles continuously, okay, continuously, so you will be able to understand also the information there. And I realized that it's not the same information, the same way in which Jepsen is showing you the information, but well, it will give you an idea and a closer look to how information is organized in aeronautical charts, standard instrumental departure charts, and so on, okay. So right now what we are doing is we have reached Motil, and right now we are going to the following point in our flight plan, okay. We are going to the following point in our flight plan, and you know, we are going to Sofia, okay, Sofia. In the right side you have the English version of a flight plan, which is basically the same, okay, because the names are international. If your name is John, in Spain you are John, you are not Juan, okay. Even if the translation is Juan, you are not Juan, you are John, and people should call you John, not Juan, okay. So names are international, and you must use the same names, okay. The holding selector, we can move the holding selector, but it won't affect our navigation, because we are following the flight plan, okay. And we have the autopilot in nav mode, and that is we are following the navigation, but we can follow the navigation of a radial if we fly in V-log mode, or we can follow the navigation of a flight plan if we are flying in GPS mode. To follow our navigation, we have to press the HDG button in our autopilot, and we are going from Motil, as you see there, to Sofia. My god, we have some turbulences there, okay. So those little changes you have seen is because air was hitting us, okay. But were minor turbulences, you don't have to worry, okay. A little bit of air in touching the fuselage of our aircraft, okay. So as you may see, we have the yellow arrow center, and we are following the next point in our flight plan, okay. So this is a peaceful flight, it is completely relaxed, okay. I will again move a bit, well, not yet, okay, but I will consider if I reduce a bit the blue lever later on. Again, I'm giving you an exterior view of Prepare, okay. What I like from Prepare a lot is that these guys of Lockheed Martin made an amazing job, because they took the simulator from Microsoft, and the performance of the simulator has increased amazingly, and it's amazing, and we love that, because that was very important. Microsoft had a different philosophy, and you know, Lockheed Martin had military philosophy, so these people, these guys and girls working there also know very well how to do the things, okay. Take a look at the steer temperature, 7 Fahrenheit, that will be minus 13 degrees Celsius. So we will activate the pitot heat and the propeller de-ice, because if we don't do that, we could have a fatal accident. And if you consult that, okay, if you type in Google pitot heat accident, okay, you will get real flights, okay, that had accident for not setting properly the pitot heat. And by the way, the pitot heat is that, okay, pitot heat. The pitot, by the way, has an unfortunate name in Spanish, because do you know what pitot means in Spanish? Penis. Exactly that. Well, not that exactly, but the spell is very close to penis. Okay, so it's something that is a bit complicated. And that thing of pitot, by the way, it has a kind of resemblance. Okay, but anyway. The name of pitot is because the French engineer had that last name, okay? And Henry Pitot, if I don't remember bad. And we don't want to have, I want to be very serious about this right now. We don't want ice there, because if we have ice there, the anemometer will show us a fake value for the speed. And you know what happened? That if you get a fake value for the speed, the problem will be that autopilot will be completely full, and it will be doing random things, and we will have a fatal accident. So it is very important. It is extremely important to activate the pitot heat tube, the pitot heat system, to avoid the pitot tube can get frozen and we will have an accident. Okay, and take a look to the exterior view. Okay, see that we are flying 15,000 feet. It is extremely relaxing. Okay, we see the ground, there are people living their lives. Okay, and we are there so high, so peacefully, and so safe, because our aircraft is properly configured, and we are going to a magic place, Ibiza. So the flight, because we were departing, I don't remember what the hour, but I think we were departing 10 o'clock, so I think we will be reaching Ibiza more or less 14 o'clock, and nice time for lunch. In Spain, we used to lunch for 14 o'clock, 15 o'clock is the universal time here for lunch. I don't know, in the United States, I guess, to lunch before, right? And you like brunch, and you like to do a strong breakfast and things like that. Well, here we have a Mediterranean culture. That is only a coffee and go to work, which is not very nice. Okay, sometimes you need the eggs and bacon. It's better. Okay, and well, I am showing you the exterior side. Although it's not very healthy. I am showing you the exterior side, and as you may see, we have the horizontal component properly centered. Okay, and we are reaching different waypoints in our flight plan. Okay, and we have also, if we move the wheel there, that button, we can, and if we press it, we can enter inside the values that it is showing us the screen. And remember that the lower side is controlling the secondary pages, and the upper side is controlling the main pages. And we can have information about the close airport to us, information about our flight. If we have the horizontal component center, we can also reach approach settings, frequencies. For example, we can tune the ATIS frequency from the Manises airport in Valencia to see if we reach it. And yes, we are reaching the information from the Manises airport. And remember what I told you before about cataloging information whiskey. Okay, we are having there the temperature, the dew point, and very important, how to calibrate our altimeter. And the altimeter calibration should be 29.92. Very important. Okay, we have something that you will find in charts that it is called transition altitude. And remember this: on initial contact you have whiskey. That means that when you talk with the airport, with the control tower, remember you must tell them you have whiskey. And that is not that you like whiskey, because I also like whiskey, okay? But it's not that. It's that you have information whiskey, not that you have illegal whiskey inside your aircraft, okay? It's not that. It's that you have information catalog with double E, and that means exactly whiskey. Okay, so we have that, and we have also information about how we need to set up the altimeter. And remember one thing, you will see well, I will tell you this later on. Okay, we will take a look to the enroute lower eye space. Okay, and I am showing you not the full chart because it is very wide and huge, and we won't be able to see that, but we see our aircraft there. We are going to Astro, which is our next point, okay, to fly. And remember that when you take a look at the charts, sometimes in the star charts or standard instrumental departure charts and seat charts, you will find something that is called TA, and that is transition altitude. And what that means? That means that when we fly below this altitude, we need to calibrate the altimeter with the parameters that are told to us with the air traffic controller or the ATs. And if you fly to the altitude established in the TA, transition altitude, or higher, then you will be able to apply a standard setting, and that standard setting is 29.92 inches of mercury. So when you reach the transition altitude, remember to calibrate the altimeter to the standard setting, and that is the universal 29.92 inches of mercury. And below the transition altitude, as it will be indicated in the chart, okay, you will need to calibrate it with the information of the ATs or the information of the ATC. Remember, recommended power settings, okay? We are flying 15,000 feet. We don't have that in the table, so we take 14,000 feet. 20 degrees reach from the peak, 14,000 peak, temperature minus 20 degrees Fahrenheit to 12 degrees Fahrenheit. Our recommended power speed settings are 123 HIAS. That is not indicated airspeed, and that is also indicating you the QTAS, the QTAS, that is the not true airspeed. Okay, and we were talking before about indicated airspeed and true airspeed. Okay, so please don't force me to repeat you that. You can rewind the video if you want and to grab this information, okay, as well. But remember what we said about true airspeed, that the aircraft, when it's flying higher, it's raising its altitude, the air is slowly dense, and the aircraft tends to fly faster. For that reason, it's not enough to know the indicated airspeed. We know to calculate the true airspeed. Okay, so remember we are having the pitot heat activated, the pitot heat system activated, and the propeller de-ice activated, because we don't want the propeller get frozen. Okay, if the propeller get frozen, we will also reduce the performance. Okay, we will turn on the floodlights. Okay, I am switching from different views inside the aircraft, and right now I'm giving you a sight from the seats, from the passenger seats. Okay, I am moving so you can experience a bit. By the way, I did a different video in which I'm showing you from different angles the landing. Okay, so I did an additional video to this video. In that video I don't talk at all, so you won't listen in Spanish or English. You just will see the aircraft landing. Okay, and I'm moving. Okay, I'm moving. I'm not doing right now a tutorial to tell you how you can move inside. Okay, I am having in mind to do a tutorial about how to configure the keys and everything. Okay, but right now I'm moving inside the aircraft, and I am showing you how you could experience the flight inside the aircraft from different positions, and those are the rear seats. And just take a look, because everything is properly set up, everything is properly configured in the flight systems. So we have some time to relax and take a look to the window. Okay, and you will see the beautiful landscape we have there. It is absolutely amazing. Okay, and it's very nice, very close to real life. That is the good thing I like to prepare, because the skies in Prepare are quite better than in X-Plane. Okay, and for my taste, the ground in X-Plane is quite better than in Prepare. So I think that well, both simulators have differences. Okay, X-Plane, in my opinion, deal better with the ground textures, and Prepare, Lockheed Martin Prepare, deal better with the sky. Okay, the clouds and everything like that. Okay, so we have reached Astro, and right now we proceed to go to the next point in our flight plan. And you know where we are going right now. We are going to NANDO, and we are going to NANDO, and we need to descend to 7,000 feet. And take care with this, because when you are descending, what will happen is your speed will increase. So we will need to take care of the anemometer, and also to reduce our speed with black lever and also the blue lever. See how our vertical speed indicated, see how the variometer is telling us our descent rate, and also see how the value of the anemometer is increasing. So we don't want to reach a dangerous speed, and because we don't want to reach a dangerous speed, we need to limit the fuel. And when we limit the fuel, we get some warning. You see gear up, but don't worry about that. That is completely normal. Okay, we're doing the descent checklist. So altimeter is set, cowl flap closed, power as required, and mixture is enriched as required. We are too high, so we don't need to enrich mixture yet. Okay, we will enrich mixture when we get 4,000 feet or more or less an altimeter value like that. Okay, the red indication, the one in there, is completely normal. The aircraft is feeling that is having less power, and it is thinking this guy or this girl probably is going to land. So I will remind him or her to use to put the gear up. Okay, to use the gear. Well, this is not the case. Okay, the aircraft is smart, but not so smart. Okay, if the aircraft was absolutely smart, it will fly completely alone. We won't need a pilot. Okay, so yes, the aircraft is very smart, but not so smart. I remember I was in a government place, and I was asking to the clerk working there, I was asking for some paper, and told me, no, our computers are smart, but not so smart. Remember that. Okay, here you have the same problem. The computer here is smart, but not so smart. So don't pay attention, or pay attention to that warning, but don't worry, because we don't need the gear up yet. Okay, and I don't know if you remember the indication of the manifold pressure, but because we need to reduce a lot of power, because the aircraft is flying with its own weight. Okay, have in mind this weight a lot and is descending, so its own weight is pushing the aircraft to the ground. Okay, so if we're pushing the aircraft to the ground, we don't need to apply more power, and when we cut the power, it's completely normal. We don't have any value in the manifold pressure instrument. Okay, so don't worry about that, because even if when we are descending, it is not in the comfortable zone, that is the green arc of the manifold pressure gauge, we won't have any problem at all. If you're coming a track and you have a lot of load inside the track and you are descending a mountain, okay, you don't want to apply more power, because you will really have a problem when taking curves. Okay, so you don't want that. Okay, so in this case it's completely normal. I am showing you the manifold pressure instrument. Don't be in the green arc, in the comfortable zone. I am showing you a sight from the co-pilot area. Okay, from the co-pilot seat, and it's extremely beautiful. So just imagine you are flying with me, and we are here. Okay, we are going to Ibiza, and we are descending little by little. Okay, and we will be reaching. We need to reserve energies, human energies, for the landing, because we will need to understand many things that like as descent rates. Okay, in the time it's almost 12 o'clock, so I think we will arrive in time for lunch. Okay, in time for lunch. I think we will arrive in time for lunch. So when we will descend, and we follow the star chart and the IAC chart, the instrumental approach chart, we will need a lot of energy, because we will need to be focused and to concentrate in the approach, and we will need to understand several things. Okay, so we'll do that. And right now, what we will do right now, we will reduce a bit the blue lever. Okay, because we don't want the speed increase as long we are descending, and we are also reducing a bit the black lever, because we want to cut more the speed of our engine. Okay, we don't want so much speed. Remember, the aircraft has a lot of weight, or has its weight, and is descending. And what do we have there? The beautiful, amazing magic and fantastic sea. And I promise you that the sea in Ibiza is wonderful. It's like crystal water in kind of shades of green, blue. It's a magic island, okay? Magic island. You have many places to visit there. You have the best discos in the world, all famous DJs worldwide. It's a kind of mecca place, okay? It's a kind of place to go. All famous DJs from Europe go to Ibiza. It's a reference point, okay? If you want gambling, where do you go? Las Vegas, right? Okay. If you want music, Ibiza. If you want disco music, Ibiza, okay? You have Las Vegas in Nevada, we have Ibiza in Spain. It's not Las Vegas, okay, but it's a reference point for disco music and fun, okay, and beaches and things like that. I remember that, when I was listening English and I used to spell the word beach, all people were all the time ha 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 ha, and I did not know why, okay, but later on I understood why. Okay, anyway, we are very close to Ibiza, okay, or not very close, but we are reaching it, and more or less we have 1 hour 20 minutes of flight, more or less. I'd say, if I have in mind our flight plan, okay, and we will be arriving Ibiza very soon, okay. Also because when we are reaching when we proceed with the descent, it won't be so hard. Well, it will be hard, but it will be more funny for us, okay. So I'm giving you also some eyes there, as you may have seen, telling you the gauge you need to monitor. I will control more the revolutions, and I will cut more the speed for engine, because basically we are gliding. Because we are descending with the own weight of our aircraft, so we don't need to put more engine power, and it's completely normal that we have an extremely lower value in the manifold pressure gauge, because basically we are gliding, okay. We don't need to put power because we don't need to fight against gravity, and we don't need to defy anything. We don't need to defy gravity, okay. We are using our own weight to glide, okay. That is what we are doing. For that reason, you have a lower value in the manifold pressure instrument, okay. But remember, we are following basically the green arc, so we are in the normal operation speed, and perhaps we are not following the recommended speed for the cruise power settings, but we are flying in the green arc, and that is, we are in the safe area, okay, safe area. And because we are descending with our own weight and we are gliding, this won't affect also to our fuel performance, and that means we won't pay more, okay, talking in plane wars, okay. So we are more or less to 126 knots. We are perhaps 23 extra knots beyond of the recommended cruise power settings, but that is nothing. That is almost nothing. So because we're reaching right now 7,000 feet, now we will see the aircraft is not gliding anymore, and we are not using its own weight to glide anymore, and then the speed will decrease dangerously. So to avoid that, we will need to put power settings inside our engine, and right now we will have to move forward the black lever, and right now we'll have to move forward the blue lever as well, okay. Remember always to monitor the exterior temperature at the altitude, because we will need the valuable information to use the cruise performances tables. And as you may see, again we have a value in the manifold pressure gauge, okay. So right now we have a value there because we are applying power to your engine, and it is given the inches of mercury of the fuel mixture, okay, inside our engine. And right now we have a temperature, a different temperature, of course. We have 36 Fahrenheit degrees there. So we are flying to a lower altitude, and remember that when we are descending, we need to enrich the mixture. But don't worry to enrich the mixture right now. At different points, that means at different altitudes, we will be calculating the EGT peak as a reference point, as I said before, to decide if we fly rich or if we fly thin. By the way, we have a road there, and I bet you we have cars there moving, okay? Because on the ground we have people living their lives, and that is what is magic about to fly a simulator, okay? That you see the animated grounds and everything like that. Okay, I'm giving you an exterior view of the aircraft, okay? That was a livery. It cost a lot of time and effort to use the livery. Was we were editing it in Photoshop and in Adobe Illustrator all the time, okay? And took us a lot of time. And I'm giving you some exterior views, and the exterior views of the aircraft you have there is magic. We are very close to Alicante because we are going to the Alicante VOR DME. We won't follow any radial from this VOR because people could think, well, if you are flying to a VOR, you will follow a radial to get the VOR. No. We are just flying to the geographical coordinate of that VOR, and that is enough, okay? We won't be following, in this particular case, any radial. And when we be landing at Ibiza, yes, at that point, we'll be following a radial, okay? So I want to clarify that. I want to point out that, okay? And again, our aircraft, our tail number is ACND1, and you won't say that. You will say Echo Charlie Mike Victor 1, okay? So our tail number is Echo Charlie Mike Victor 1, and that is a livery and the name of our aircraft, Virgen Macarena, okay? Which is a very famous sculpture in Spain, in Seville. I invite you to come here and to visit the Macarena Virgin, okay? You just drop out from the plane and ask to a taxi driver for the Macarena that you want to see it, and you will get that, okay? We have a bit of turbulences there, but don't worry because just a bit of turbulences. For that reason, remember what I told you about the green arc and never fly in the yellow arc, because when you fly the yellow arc, okay, you can enter in the risky zone, and that is crossing the red line. Remember, never cross the red line, okay? It could compromise the safety for our flight, okay? There we are flying to 140 knots, and what we will do right now is to reduce the cruise power settings to reach more or less the recommended cruise power settings in our cruise performances tables that we were taking a look to them, and perhaps we will consult them again, okay? But remember our recommended power settings, okay? Recommended, not compulsory. So you can follow those power settings if you want, okay? You are not forced to, okay? So we are applying right now a bit more of blue lever, more RPM, because we don't want to limit the speed of our engine, and we are applying a bit more of black lever to give a bit of more power to the engine, okay? And we are very close to Ibiza, okay? And the manifold pressure instrument again is showing us the value. I don't see very clear information, perhaps 23 or 24 inches of mercury. So if we will have to decide what cruise performance charts to take, if we are having a value of 24 inches of mercury, we will have to use the 25 inches of mercury chart, and it is recommended to fly rich, okay? So we will have to use the rich cruise performance table for 24 inches of mercury. That will be the 25 inches of mercury, with a cruise performance table of 25 inches of mercury, and a rich cruise performance table, okay? 20 degrees rich from the peak, or off the peak, okay? We're getting closer and closer to the sea, as you may see that, okay? And very soon I will be showing you, remember the magenta line, which is a flight plan, okay? Very soon I will be showing you the flight plan, okay? And the next point we will be flying, and you will see that. You can see also in the digital instrument the RPM we are having. That is 2,000, 1,900, 2,000 more or less, 2,000 RPM, okay? That is the RPM we are having. And remember that when we apply black lever, what we are getting? More value in the manifold pressure. See that if I push forward the black lever, automatically I get a different value in the manifold pressure gauge. Okay, see that, because it's very important. What we told before about air pressure, the engine, the fuel pressure, that is different from the exterior air pressure and everything like that. Okay, I gave all the technical explanation before, but remember, I am a strong enemy to use complicated words or technical words. For technical information, you have Google. You have a lot of amazing information, complicated information nobody can understand. Okay, so I prefer to summarize that information with examples that perhaps are not very accurate, or perhaps are not all the time proper or correct, but it will give you an idea to understand that technical information. Further, later on, you can get more information about this in a technical way. Okay, so if I press the A button, I can switch again to the black view to get a sight from the black rear, from the back, from the rear seats of our aircraft. Sorry, I am a bit tired. Sometimes I even confuse the exterior color of the aircraft with the rears. Okay, because I have 4 hours talking a foreign language, and that is English. Okay, because I am speaking in a foreign language. Okay, so you have to have patience with me and give me sometimes like the same thing you give to the horses, a sugar cube. Okay, so we're flying, and a sugar cube to give me more energy because I'm getting exhausted. Okay, we are going to Ibiza, and we are very close to the sea. And if you see there, we take a look to the road there. I don't know if we can see cars there. I think we have some cars. Do you see the cars moving? Those microscopic points moving, those are cars. We have cars there. So people is alive. We are not flying in a dead environment. Okay, so we are flying in a place where we have life. We have life on the ground. Okay, and you have cars moving. You can configure also those settings in Prepare to increase the number of objects moving, that is, increase the number of cars, the number of boats, and stuff like that. Okay, so I switch again to the pilot seat. Again, I will avoid the sun hitting me in the face. Okay, because I want to read properly the instruments, and very soon we will be in the sea. Okay, Mediterranean Sea, and we will be very soon close to Ibiza, and we will be ready to understand the standard terminal arrival route, that is the star chart, and also to understand the IAC, instrumental approach chart. Okay, so take a look to the flight plan in our GBS, and we will be reaching very soon the VOR, the Alicante VOR. And remember what I told you before, that we won't reach that VOR by following any of its radials. We will be reaching that VOR just by flying to its geographical coordinate. Okay, I want to emphasize that again. Okay, so just take a look to the beautiful side of the coast we have there, which is extremely beautiful. The Valencia coast, Alicante coast, magic place. We in Spain, we have, I like to compare Andalusia, which is the place where I am right now, and I want to compare Andalusia temperatures with California. It's very similar to California, very, very similar, because many times I see the temperature in California and I see the temperature in Andalusia, and it's basically the same. So Marbella in Malaga has more or less the same temperature than you will experience in Los Angeles. Okay, of course we have exceptions, and sometimes we have winter a bit cold, but most of the time you can say we have 7 months of 4 months of spring, 3 or 4 months of intense summer, and 2 or 3 months in south of Spain of soft winter. Okay, and of course you will never get ice in places like in Minnesota or places like that that you see a lot of ice. You say, my God, how people can survive in those places? I don't know that. I am in the Californian side of Europe, okay? So I don't know how people can survive the ice in the windshield of the cars and the streets and everything. I don't know. I think I would die if I was living in Minnesota or in places, or Chicago or Boston. By the way, why people from Boston have that beautiful accent? I don't know. I love that. I love that accent. It's my beautiful accent from the United States. And so if people is watching this video from Boston, I want to say a big hello, a big hi to them, because I really love how people spell and how people speak English there. I would like to copy that accent, but I don't think it'll be very successful doing that. In fact, I don't know if I sound like coming from outer space or coming to a different place. I don't know, but anyway, I love the Boston accent. People speak, of course, people speak very nice in all places from the United States, you know, but Boston is my favorite accent in the United States. Okay, we're reaching the Alicante VOR DME, as we DMA, as we said before, and DME. And right now, because we have reached that point, I wanted to show you from the rear seat the sight we can experience when we are reaching a different point in our flight plan, and when the aircraft is moving. Okay, so I wanted to share with you this sight because I think it is magic and it is beautiful. Okay, so I wanted to show you this sight, and this sight is very, very, very nice. I will switch again to the pilot seat. Okay, I will take a look to the next point, and remember, we are going to the next point in our flight plan. That is, we are going to meet us, and again we need to descend to 4,000 feet. And when we are descending to 4,000 feet, remember what will happen. What will happen is the weight of our aircraft will push it forward to the ground, and the aircraft will tend to glide. So again, we will have to reduce the engine power by reducing the black lever, by moving the black lever rearward, and by cutting also the RPM with the blue lever. So we have to control the speeds, okay? And for that reason, I put you the eyes there to tell you the gauge you need to monitor. You need to monitor the altimeter is decreasing the altitude, that our descent rate is okay in the diameter, and that we are not getting into a big problem, into a big mess if we have a higher value in the anemometer. So for that reason, you need to cut the engine power by moving rearward, the black lever, and also by limiting the speed power by limiting the RPM with the blue lever. And again, as we had before, you will have lower values in the manifold pressure gauge, which is completely normal. Again, do you see the manifold pressure? We have a value outside of the green comfortable zone of the green arc, but don't worry about that because we are descending. And again, because our aircraft is not so smart, it's telling us that perhaps we would like to use the gear, but we won't use the gear. We don't need the landing gear yet, okay? We are just descending because we are getting closer and closer to Ibiza, to the magic island, and we are going to meet us. That is a white triangle, so it is not compulsory. You notify you are there, so you don't have to notify that. Because we are descending, again we have to calculate the EGT peak. So remember, move forward or rearward the red lever until you get the needle in its higher position, that is its peak, and then move again the red lever forward or rearward a bit, slightly a bit, to make the temperature drop again, and the quantity of degrees that is indicated in the cruise performances tables, okay? In this case, 20 degrees. 20 degrees reached or 20 degrees lean, okay? That is what we need to do. And again, we are having a magic sight of the exterior view we have there, that we are very close to Ibiza, very close. We are getting very close, closer and closer to Ibiza, so I think we will land in approximately 1 hour. In 1 hour we will be landing there. We will be following step by step what a real pilot will do to proceed with the VOR DME approach. and that will be understanding basic settings as what is a descent road, how can we calculate the opposite radial to get into the runway, when we have to disconnect the autopilot to fly manually, because I remember you that this is not a precision approach. If you want a total precision approach, you need to use the ILS, okay, instrumental landing system, because the ILS is the only precision approach you can get to land almost automatically your aircraft. But when you are proceeding with a VOR DME approach, you are getting non-precision approach, okay, and that means exactly that you will need to control other things in your flight, like the vertical component, because the aircraft can get aligned with the radial, and that radial could be in front of us because we could have a VOR DME station in the airport, so we can get a line that casualty is close to the runway, that VOR station. So the VOR station is close to the runway, and we are following a radial from that from that VOR station that is close to the runway. But that will only align our aircraft more or less to the runway, because casualty we will have a radial that is crossing in front of our runway, and we will be able to align more or less, okay, but not with total precision. And also we will need to calculate the descent, and to calculate the descent we need charts. Yes, we need charts. If you can grab Jepson charts, get Jepson charts, because they are beautiful and amazing. They don't have strange colorful information, they are black and white, because it's the only thing you need to read the charts properly and to avoid to get distracted, because we don't want to see the beautiful color of the mountains, we want just to understand the information. So I like how severe how the discipline you can find in those charts. I like that, okay. AERONAUTICAL charts are more beautiful, more colorful, but also very, very beautiful charts, okay, and you can get a lot of valuable information there, okay. So I'm showing you right now, we will be sending a bit, because we will be increasing a bit the power for our engine, because we are not gliding anymore, and because we are not very high, we can turn off the settings, okay, for the pitot tube, because we don't need to hit the pitot tube anymore, okay. We don't have a very low temperature side, so we won't get ice inside it. And again, we have to calculate the EGT peak, and again, when we have calculated the EGT peak, we need to decide if we fly enrich or LEMD, okay. Again, see the manifold pressure instrument that is showing us value, an SAT value of 20 inches of mercury, and the exterior temperature is 46 Fahrenheit, okay. And what happened, take a look also to the anemometer, we are in the recommended power settings, okay. But if we take again the cruise performance settings, and having in mind we are flying 20 degrees reach from the peak, or of the peak, and we are flying to 4,000 feet, remember our exterior temperature from 12 degrees to 48 Fahrenheit, we need to follow, in this case 138 indicated airspeed keys, or QTAS, true airspeed. So our recommended power settings are, as you may see, there is a minor difference of just 1 knot, okay. Our recommended power settings will be 138 knot to that particular altitude and to that particular exterior temperature, okay. And remember, the performance cruise setting we should get is a chart of 21 for the manifold pressure value, okay. If you get the chart, don't worry, because the variation in the speeds are so minimal that you won't do anything that will cause a fatal accident. Don't worry, you get confused and took a chart, and the chart for the value of 23, okay, you won't die, okay. It's an error, it's not good, but you won't die, don't worry. It's not a fatal setting, okay? Something fatal is you do not hit the pitot tube. Something fatal is you do not descend with a proper configuration of flaps, with proper flap settings. Something fatal is that you do not set up properly the configuration for your aircraft to take off, and you apply full flaps. For example, when you don't have to apply full flaps, you don't get enough speed, and when you ascend, you're entering a stall and you crash miserably and you die. Those are fatal settings, okay? But if you get confused in just one knot, you won't die, for God's sake, okay? And this is only a simulator, remember that. But if you want to be serious, we need to be as close as possible to the real life, okay? See that sea, okay? See the site we have there. It's absolutely beautiful, and we are getting very close, very close to Ibiza, okay? Very close to Ibiza. So this is a very nice flight, and we are almost reaching Ibiza. I'd say that we have pending 50 minutes of flight, and we will land approximately in 45 or 40 minutes, because we'll need the 20 extra minutes to park the aircraft. So more or less in 30 minutes or 40 minutes we will be landing. So get ready, because also we'll need your help with me to tell you how to understand the charts, okay? And I will need your help, because if you were flying with me and virtually, because I'm not a real pilot, I must clarify that I'm not a real pilot. I am not authorized to provide flight training information, because I'm not a real pilot, but I like to fly as accurate as possible as a real pilot could do, because I have friends flying in airline companies. I have a friend flying the 737-800, and many of my friends are flying airliners, so I want to fly as accurate as possible. I want to deal with as technical information possible, because I always interested to fly as accurate as possible, also because I wanted also to be commercial airline pilot, and I was not able to do that, okay? So sadly it was not possible, but well, for that reason I am on the ground flying simulators, but I like to fly them as accurate as possible as a real pilot will do, okay? Anyway, I think it is very necessary to fly a simulator in a serious way. So, well, right now I am showing you the GPS again, and as you may see, we are very close to Mitos. So we are reaching Mitos, and as soon we reach Mitos, we will follow to the next airway. And I want to show you also that if we visit the nearest board page that you see there, there we have the India Bravo Alpha, which is the identification for the IBIZA VOR, and there you have the frequency, okay? And we will tune that frequency, reserve frequency, okay? So we will tune 117.80 in the navigation radio 1, and we will have this frequency in the reserve frequency, okay? And later on, when we need that frequency, we will switch that frequency from reserve to active, okay? And when we do that, we will be able to follow radials from the IBIZA VOR, okay? And that is the VOR that we will need to land, okay? Because this VOR is close to the runway, and that is the idea behind VOR DME approach. Many airports have VORs close to the runway, and the idea is you align with a certain radial of that VOR, in the sense that you also get aligned with the runway. And if we press the button, the audio button for the NANDO ONE radio, we will see that we have reached. Do you listen that we have reached the range for the IBIZA VOR. So we are receiving the signal of the VOR, and then we can consequently follow radials and operate with that VOR in our navigation radius, okay? But as I was telling you, the idea of a VOR DME approach is that many airports have a VOR close to the runway, and what the VOR DME approach do exactly is that it helps us to align our aircraft to a certain radial of the VOR, okay? That is basically the idea behind a VOR DME approach, okay? I am showing you a beautiful exterior sight, okay, so you can see that, and also the livery of our airplane that cost us a lot of effort and hard job in Illustrator and Photoshop, by the way. And well, what I was telling you, which and I prefer to talk about this because this is what really matters here, and the important thing is that the idea behind a VOR DME approach is what I told you before, that many airports have a VOR close to the runway, and you to align with the runway through a VOR DME approach, you need to follow a certain radial that is crossing in front of the runway. So when you follow that radial, you get aligned with the runway. But remember, you will get aligned with the runway that is from left to right, or from right to left. That is the horizontal component. When the aircraft move to the left or to the right, that is the horizontal component, okay? The aircraft won't descend, okay? I want to emphasize that the aircraft won't descend. You have to program a certain descent rate when you reach a certain point, and that certain point, it's called the last segment of our approach, which is called, by the way, final approach fix. If we were using a precision approach like an ILS, instrumental landing system, then that point will be the FAP, final approach point. But because we are proceeding with a VOR DME approach, the last segment for our approach, it is called FAF, final approach fix, okay? And how much you must descend? How do you program that descent rate? Well, according to the recommended landing speed of your aircraft, okay, we will have tables in our charts, exactly in our instrumental approach chart, and that table will guide us about how much we have to descend this bird, okay? And also, it is very important that when you reach, I don't know if you see VISA there, and very important that when we reach a certain point in which we have to start the descent, and that is the last segment of our approach, the FAF, the final approach fix for our kind of approach, that is a VOR DME approach, okay? When we reach that particular point, which is the last segment of our approach, then we also need to stay to a certain altitude, because just imagine you are flying to 70,000 feet. The U2, and I am not talking about the epic, fantastic, wonderful, amazing, and beautiful music band, okay, which I admire and love a lot, U2. No, I am talking in this case about the spy plane, okay? So just imagine you are very, very high, okay? Even in that case, a descent rate won't work. So the descent rate work only and only if you are in a certain altitude, in a certain point, and that point is exactly the point I told you before, FAF, final approach fix, okay? So there you have a beautiful sight of our aircraft. Don't worry about everything that we are talking about, this is very technical, okay, but don't worry about that, because we will see that little by little, step by step, and you will experience the landing step by step. And by the way, reserve energy is because we are very close to the runway. Basically, we will be landing in 30 minutes, and more or less, and we will be landing in Ibiza, and reserve all your energies to understand the charts and to proceed with the real procedures a real pilot will do with me, okay? So reserve all your energies to understand and to work and to organize the work, because it is very important to organize every single step of what we will do in the next minutes. Okay, so right now we have the Ibiza at the bottom, okay, and we are reaching the next airway very soon. We are to 5 nautical miles. Okay, very soon I will show you also the flight plan, so you can have an idea of how close we are from Ibiza. Okay, and we have a very nice site. Okay, and when we be even more closer or even closer to Ibiza, you will realize that the VOR DME approach is not very complicated to do. The only you need to do is a bit of practice and of course charts. Okay, those are the cold flaps, by the way, that when we have to operate that, you know where are the cold flaps. And if you take a look to the anemometer, the speed values are perfect. We're using the proper cruise performance tables. We are flying in rich mixture. With rich mixture, we have calculated perfectly the EGT peak for our engine, so we have perfectly optimized the combustion of our engine, and everything is fine. Okay, everything is fine. The autopilot is working as it should, and Ibiza is there. Okay, so we will land very soon. Okay, and when we start to land, the first thing we are going to do is to use the standard terminal arrival route, which is the first chart we have to use and the first charts pilot use. By the way, we are reaching Bruno. Okay, you see Bruno, which is our next airway. Okay, and as soon as we reach Bruno, we will connect with the next airway, or I don't remember it right now, but when I take a look to the flight plan, I will tell you if we continue to the next airway or if we connect directly with the star chart. Okay, so basically we are going from Mythos to Bruno, which by the way is airway in which we don't have to, it's not a compulsory notification point because it is a white triangle. Okay, so we are reaching Bruno, and as soon as we reach Bruno, you see that we have the next segment of our flight plan in magenta. Okay, and if I show you an exterior view, there you have the magic, beautiful, and amazing Ibiza. Okay, so the last airway we will reach in our flight plan is Reset, and then we will connect with the star chart. Also remember that I am giving you the Jepson equivalents. Okay, and I want you right now to read that with me. Depart from IF till now to the IF in our navigation, run 085 degrees until reaching 3 nautical miles from the Ibiza VOR DME. In that moment, we will have reached the IF intermediate fix. What I am showing you there is are the abbreviated procedures to proceed with the VOR DME approach, and that I am showing you right now is the instrumental approach chart. Yes, I know we need to use before the star chart, okay, but I want to show you the instrumental approach chart because I want to show you that when we reach that point, which is the first segment of our approach, the initial approach fix, what we will do when we reach Tilno is to move forward to a certain rumb, and that rumb will be 085 degrees. Okay, don't worry, because right now what we will be doing right now is to select the proper radial that will align us with the runway. Okay, so remember that wheel is the omnidirectional bearing selector and allow us to follow radials. And take a look again to the instrumental approach chart. Okay, and take a look to it, and if you see that there, you see radial 244. Okay, and you have the VOR identification in the Bravo Alpha. But remember, the radial 244 is departing. Okay, so if you follow that radial, you will depart from the VOR, and this is a very common error because you are not going to Chicago, you are going to Ibiza, okay? You are not going to Los Angeles, and if you follow the 244 radial, probably you will go to Los Angeles. So no, you need to follow the opposite radial, and that is the 064. And to calculate the opposite radial, I give you a little trick, and you have to add 180 degrees. Okay, I will show you a trick later on. Okay, but right now we will put our mixture to full reach, and we will have full RPM, and also we will tackle the descend checklist that you assume also that I already did properly this descent checklist, which basically is having the maximum RPM possible, and also having the block lever pushed forward, because we need our mixture in full reach, or in full, no, I won't say full reach mode, okay, but we need our mixture full reach, because also, and also our blue lever push forward to have the maximum RPM possible, because we don't want to limit our speed, okay? So we need that extra speed, all the possible speed, all the possible performance to make our engine can work properly in an emergency situation. For example, we don't see the runway, we have to miss the approach, and we need to do certain procedures, so we will need that extra engine power, okay? And we are reaching till now, and when we reach till now, we will start with the real thing here to proceed with the VOR DME approach. So remember that when we reach the first segment of our approach, we will depart from it following a certain ramp, and that ramp is 0.85 degrees. But don't worry, we'll see that little by little, okay? I want you to focus right now in the nearest board page and take a look to the distance we are from the IBIZA VOR DME, just to know when we reach the first segment of our approach. And also I remind you the landing approach speed we need to use. For real aircraft, we have also performances for landing, performances for taking off, etc. By the way, I have applied flaps, and remember what I told you when you apply flaps. The nose of your aircraft tends to rise, then stabilize, okay? But if you apply trim, if you apply the elevator trim, you can compensate that, okay? And right now I will show you what is a VOR DME approach very fast. A VOR station in the ground is a facility with antennas that is broadcasting magnetic rumps, okay, like a compass, like if you had a compass in place on over the ground, okay? And by the way, that picture is a VOR DME station if you have never seen one, okay? So the goal here is to follow a certain, to reach a certain point called FAF, final approach fix, okay? And you must just stay at that point to a certain altitude, for example 3,000 feet. And what happened next? Well, what happened is you start the descent rate according what is indicated in the table, in the instrumental approach chart table, okay? Some question. Can you proceed with a VOR DME approach without a chart? No, that is completely impossible, okay? To proceed with the real VOR DME approach, you need a chart, okay? The instrumental approach chart, and exactly an instrumental approach chart that is giving you the procedures for a VOR DME approach to the runway, okay? So if you have seen something in forums that someone have a magic trick or something like that to do a VOR DME approach, that is a magic invention or something like that, okay? But it's not what a real pilot will do. And right now I'm showing you the instrumental approach, no, sorry, I'm showing you the star chart, okay? And in the star chart, which is the first chart we will use, the star chart is a very simple chart. Basically it has only one point, and what it's telling that chart is that we need to reach the first segment of our approach, okay, which is the initial approach fix. And I recommend you, strongly recommend you to press the pause button in the video to read all that, because you will need to understand very well the segments involved in our approach, okay? And the star chart basically tells us this, that we will reach the initial approach fix. That is the first segment of our approach, and it is giving you information about when you reach that point. And that point, the initial approach fix, is, by the way, called till now, and we are very close to it. Very close to it, okay? You can see that in the GPS, okay? So when we reach that, we will have to work a lot, believe me, because we will need to program every single thing in the autopilot. We will need to cancel charts all the time, and we will need to be very concentrated, okay? We'll need to stay focused completely in our landing, okay? So take a look at the anemometer. We are almost to 80 knots, okay? So right now I will put the gear down, okay, because we are almost to 80 knots, and I want to start the descent, okay? I want to start the descent very soon right now. And as you can see, I'm giving you an exterior view of the aircraft, and you see that we have the gear down, okay, and we are flying to the proper speed. And we will do the before landing checklist. The seat belts must be okay, the fuel selector valve is select, the cold flap as required, mixture for reach, landing gear down, landing and taxi lights as required, flaps down, and the airspeed established as normal landing approach speed, which are 76 knots. We are 80 knots, more or less. It's the same, okay? We have there the elevation of the airport, the type of approach of the chart, the altitude profile, okay, that we will discuss that later on, and the descent rates, and also the minimums, because we will need to decide if we land or not when we reach a certain point that it is called mapped, means approach point. Don't worry about that, we'll deal with that later on, okay? So right now I want you to focus in this. We need to follow the opposite radial to the radial 244, and that is the radial 064, okay? To find the opposite radial, you need to add 180 knots. Please press the pause button right now and read that text, and be sure you understand that, because to calculate the opposite radial, you only need to add 180 to the certain radial you want to calculate the opposite radial, and if the value is greater than 360, then you reduce a certain quantity that I told you there in the text, okay? I am pressing again the knob button. Sorry I cannot explain every single thing because text is going very fast. I watch also the instruments there, and I have to run, okay? So I have pressed the audio button, and as you may realize, we have range for the IBIZA VOR. Listen the Morse code. So we have range for it, okay, and we can follow radius if we need that, okay? Observe that we have our speed very well configured, okay? We are flying exactly to 80 knots. We should fly to 76 knots, but well, we have 4 extra knots. That is nothing, okay? So yes, we are flying fine, okay? And we have range for the radial because you are listening to it, and very soon we will reach the first segment for our approach, and that is the initial approach fix, okay? Take a look to the anemometer, by the way, and we are flying to the right speed, the proper speed. We have 80 knots. Should be flying to 76 knots, but it's okay. Okay, we have range for the VOR. We are very close to till now. We are to 5 nautical miles, only to 5 nautical miles. So we will reach it very soon, and our altitude is exactly 4,000 feet. Very soon we will move to a certain RAM, which is the RAM 085, as we have seen before in the instrumental approach chart. Don't worry, because I will show you this again, okay? So you will be able to understand step by step how to proceed with the VOR DME approach. The first thing I want you to have in mind right now is that we are reaching a point. That point is called till now, and that point is the first segment for our VOR DME approach. And the first segment for our VOR DME approach, or for any approach, for any VOR DME approach, is called Initial Approach Fix, IAF, Initial Approach Fix. That is the first segment. And in this case, the first segment, the Initial Approach Fix, has also the name of an airway, and it is till now. Okay, so let's say we have designated, or the chart have designated an airway as the initial approach fix to reach or to proceed with the VOR DME approach. Okay, and we are flying, and remember you that, to 4,000 feet. Okay, we are very close to Tilno, only 3 nautical miles. When we reach Tilno, we will depart following our own heading, our own ramp, and that ramp will be 085 degrees, as it was indicated in the instrumental approach chart. And remember, if I don't remember bad, Tilno is indicated also in the star chart as the initial approach fix. Basically, the star chart is a very easy to understand chart. It's a chart that is indicating as only one point. Whilst in the instrumental approach chart, we have a lot of different points, procedures to follow, descent rates, and every single thing. So the star chart is a chart that you can finish in seconds. It's very easy to understand. Okay, just 1 point and you're down. Okay, so we are right now to 77 knots. We have an error of 1 knot. That is nothing, and we are flying properly. Okay, we're reaching Tilno, just 1 nautical mile. And remember what we will do when we reach Tilno. Take a look to that, to the GPS. We are very close, very close, very close. When we reach the initial approach fix Tilno, what we will do, we will follow the RAM 085 that we have programmed already in the horizontal situation indicator instrument. Okay, we'll show you that right now. And when we reach Tilno, we will press the HDG button in the autopilot. So right now our 0 nautical miles to Tilno, that is, we are in Tilno, and we press HDG, and the HDG button will change the ramp of our aircraft to the RAM 085, which is what it is indicated in the chart. Okay, and now we take a look to the IBIZA VOR, because we need to reach that point, the IF, the intermediate fix. And how do we know we reached that point? Well, we know that because you must be to 13 nautical miles from the IBIZA VOR. And right now I'm showing you the altitude profile. Okay, the altitude profile is telling you every single point, the altitude you must be there, and also I'm showing you the descent rate table, okay, in which I'm telling you also the recommended descent rate according our aircraft landing recommended speed, that in this case are 76 knots. Okay, we will discuss later on in further detail. Okay, but right now what I want you to focus is in the nearest port page of the instrument. Okay, because I want you to be sure that we are following, that we are reaching a certain distance from the IBIZA VOR. Okay, press please the pause button to read that, because I want you to understand please all the segments involved in a VOR DME approach. We have the initial approach fix, the intermediate fix, and the final approach point for an ILS precision approach. But because we are doing a VOR DME approach, we have the initial approach fix, intermediate fix, and final approach fix, FAFA. Okay, so when we reach 13 nautical miles from the IBIZA VOR following this particular ramp, the RAM 085, at that point we will reach the intermediate fix. Okay, so you have to take a look all the time to the nearest port page, which will be the DME equipment equivalent in other aircraft. Okay, there is a little digital display showing you the distances. I will shoot down that because we don't need to listen to the VOR identification anymore. It's disturbing my ears. Okay, so again I'm showing you the altitude profile, and we are following the RAM 085. And remember that when we reach the intermediate fix, we need to stay to 3,000 feet of altitude, and see that we have programmed that particular altitude in our autopilot, and we will be taking a look to that, to the India Bravo Alpha VOR, because when that page shows 13 nautical miles, at that particular moment we will follow the opposite radial to the radial 244, and that was, if I don't remember bad, the radial 064, as I showed you before. Okay, so when we reach the intermediate fix, we will switch to follow the VOR radial, the opposite radial to the radial 244, as it is indicated in the chart. Okay, and we will follow the radial 064 that won't orientate our aircraft to Chicago. It will orientate our aircraft to Ibiza. Okay, because the opposite radial to the radial 244 is the radial that will orientate our aircraft forward. Okay, and that right now we're doing that because we have reached the intermediate fix. Okay, because we have intermediate fix right now, we switch to navigation to tell the autopilot to follow the opposite radial to the radial 244, and what our aircraft is doing is what I am showing you in the animation. It is following the radial 064, which is the opposite to the radial, which radial? The radial 244. Okay, that is what we are doing right now, and we are also programming a certain descent, because when we reach the final approach fix, we need to reach a certain altitude. Okay, and we have programmed that also that descent. Take a look to the manifold pressure instrument, take a look to the anemometer instrument. Okay, because I want you to control the black lever to reduce the gas, to cut the gas. And remember, we reach the final approach fix when we are to 8 nautical miles from the IBIZA VOR DME. Okay, and you will need to take a look all the time to that. And when we reach the final approach fix, we need to stay to a particular altitude, as it was indicated in the chart, and that altitude is 2,700 feet. And as you may see, we have already programmed that altitude in our autopilot. The anemometer is perfectly working. We have our current descent speed. Okay, and pay attention to this, because when we reach the final approach fix is when we will start the descent rate. And also I will show you, I guess I will show you, if I have time here and space in the screen, the computer screen, I will show you also again the descent rate. Okay, to indicate you what kind of descent rate you must follow. Okay, so as you may see, this is very easy to do. Didn't have complication at all. 9 nautical miles. Okay, so take a look all the time to the nearest board page, because when we reach 8 nautical miles from the IBIZA VOR, India Bravo Alpha is the identification of the VOR of this VOR. When we reach when we are from 18 nautical miles of the IBIZA VOR, at that point we will say that we have reached the final approach fix, and that is the moment in which we have to descend our aircraft. And as you may see, we are following real procedures. The real procedures a real pilot will follow to approach to Ibiza, and we have the runway in front of us, so we are doing the right thing. Okay, and we have the runway there. So please pay a lot of attention, because we are very close to reach the final approach fix. which is the moment in which our aircraft will start to proceed with a descent rate that allow us to land proceeding with a VOR DME approach. Okay, so we are very close to the final approach fix, and right now we have reached the final approach fix, and right now we start the descent rate. I will tell the aircraft to descend 200 feet, that is almost touching the water, okay, and I will program a descent rate, as we have seen before, of 400 feet per minute, okay, and I am showing you with the eyes all the gauge. You need to take a look. You need to take a look to the variometer to see we are reaching that particular descent rate. You need to take a look to the altimeter to see that effectively we are descending. Take a look also to the manifold pressure instrument to see everything is okay, and take also a look to the anemometer, because we need to maintain the recommended speed, okay? If we don't maintain the recommended speed, then the descent rate won't work. So try to maintain it in 76 knots, more or less. And the next thing we will do right now is to reach the map, the miss approach point. Take a look also to the descent rate, okay? For 80 knots, the recommended descent rate is 476 feet per minute, okay? We don't have that in our altimeter. We have 400 or 500, okay? Don't worry, program 400 or 500, okay? This is not a precision approach, okay? And if you remember in the chart also to the left side, we have the minimums, and the minimums are established to 810 feet, I don't remember, or 800 feet, okay? I don't remember well, but well, anyway, it is in the chart, okay? And when we be exactly in a particular precision that is from a distance of the IBIZA VOR of 2 nautical miles, at that point we will have reached the map, the missed approach point. And at that point we will have to decide if we land or not. If we see the runway, then we continue. So when we reach the map, we say continue. But if we don't see the runway, then we will say miss approach, and we will miss approach. By the way, the puppy lights, which are those lights you have close to the runway, have a kind of code, and I am showing you the color code there. So the idea is having 2 white lights and 2 red lights, okay? And we will be taking a look also to the GPS to know the distance we are from the IBIZA VOR, okay? Because when we reach 2 nautical miles from the IBIZA VOR, we will have reached the mapped, the missed approach point, and in that point we will decide if we continue and then we land, or if we don't see the runway because we have a lot of fog or something like that, or we have extremely bad weather conditions, then we will have to decide if we miss the approach, okay? And remember, the VOR is aligning our aircraft to a certain radius of the VOR that is crossing in the runway, okay? So consequently we are also aligning our aircraft with the runway, but a VOR DME approach is not taking care about how the aircraft descends. So you have to program that in the autopilot, having retrieving that information from the charts. For that reason, it's very important that you have the charts, because if you don't have the charts, you cannot proceed with the VOR DME approach, okay? And if you're in Spain, you are a lucky guy because you have those charts for free, and if you're in the United States, you have to pay for everything. I'm sorry, but yes, and yes, you will have to pay for the Jepson charts or get them from a friend or something like that, okay? Well, we have the runway in front of us, but when we reach the mapped, we will decide if we continue or not, okay? We see the runway because we have a very beautiful day, so we will continue for sure. But remember that because we will disconnect right now the autopilot because we have to finish this approach in manual mode. So we are landing the aircraft right now in manual mode. We cannot continue following the VOR DME radial. Why? Because the VOR DME radial is placed at one side of the runway. Okay, so minimums continue. We continue, okay, because we have reached the map, which is at 2 nautical miles from the IBIZA VOR DME. Okay, so what I was telling you before, remember that that we need to do right now, what we need to do right now is to have 2 white lights, 2 red lights. Don't worry if you don't reach that. I want you right now to listen the engine, okay, which is very important because when you apply more gas, the nose of your aircraft will rise, and when you reduce the gas, black lever, the nose of your aircraft will tend to go down. Okay, so listen the aircraft, listen the engine is very important. You integrate well with your aircraft. Take also a look to the puppy lights, and don't worry, don't be obsessed if we don't have the proper lights configuration. We are correcting that, okay? Right now we are perfect, okay? 2 white lights, 2 red lights, okay? That will change again, but don't worry because we are correcting our glide, okay? So don't worry for that. We are correcting our glide, and right now we are almost going to land, okay? And take a look also to the anemometer. We are to the proper landing speed, 76 knots. Everything is properly configured, and this landing will be so smooth that I promise you that if someone is sleeping on the rear seats, they won't realize anything. Okay, so when we are going to touch the runway, we elevate a bit the nose, and right now we have landed. Okay, as simple as that. We have landed, and that was a VOR DME approach. That was a VOR DME approach. Not complicated at all. Of course, you need charts to retrieve that information, but as you may see, it's very simple. Okay, I will do a little cut in the video right now because I want to show you, instead of departing from the runway, I want to show you. It is more interesting, I think, to show you the airport. Okay, to show you where is the platform, where are the fingers, okay, where our goal right now. By the way, we have 2 critical zones, and those critical zones are zones in which the air traffic controller then have a sight, direct sight from our aircraft, so we need to be careful to avoid to crash or collide with other traffic. Okay, right now we will configure also the cowl flaps. We'll also configure the lights. Remember, I gave you a table before to tell you how to configure the lights in every single situation. Okay, and right now we are going to proceed with the taxi. Okay, and to stop the engines when we park this aircraft, by the way. And basically we are going to park it, and as I promised you before, we have landed more or less to a nice time for lunch. Okay, so you can go to the hotel if you want to imagine this is a real flight. Okay, and lunch or something. Okay, after landing, we need the landing and taxi lights as required. Flaps up, trim tab set to 3 degrees. We'll move that to 3 degrees, and cowl flaps open. Okay, so we put the trim tab not to the neutral position, but just to 3 up. Okay, and then cowl flaps will be open. Okay, that is that thing you have there. Okay, we'll put that to open. So we have properly configured aircraft right now to proceed with the taxi, and we will proceed with the taxi, if you allow me, to go to the platform and park this aircraft. Ibiza airport is very easy. It's not complicated at all. Complicated airports are big airports. For example, Madrid Barajas is complicated. Those airports are big airports. Okay, we are talking about major airports, but Ibiza is a very easy airport, you know, because basically you get out of from the runway and you go to the platform. It's very impossible here to get lost. Okay, so we will proceed with the taxi very soon. We will go to the platform, we will park the aircraft, having in mind all what we did before, having in mind that we did the descent rate that was indicated in the table. Remember that the descent rate also you must follow is always according your recommended land speed, and also we have to decide if we land or not, because we have a point that is called mapped, okay, that is also indicated in the IAC chart, instrumental approach chart, and that point is telling us that if we see the runway we must land, but if we don't see the runway we must miss the approach. Okay, so basically we will move a bit forward the black lever and we will get some RPM. You can see that in the digital counter to the left side, by the way, 1000, 1400, 1500 more or less RPM. Okay, and our aircraft will start to move little by little, and the yellow line is the line we must follow, okay, to have our aircraft properly aligned with the taxiway. Okay, and here we don't have a magic finger like in the Nintendo or PlayStation or Xbox. Okay, we don't have magic fingers to indicate us where we must park our aircraft. If we want to follow real procedures, what we need to do is to consult the chart and to follow the taxiway to find ourselves the place where we need to park our aircraft. And that is what we are doing right now, because we are following the yellow line. We have the platform in front of us. I can see from my seat right now the fingers. I don't know if you see the fingers there. Okay, and in front of the fingers we have the parkings. Okay, so we'll park our aircraft very soon, and you can take your baggage if you want. As soon as I stop the engines, you open the door and you can go to the hotel very soon. Okay. Okay, so we are right now going to park the aircraft and we will move forward. As you may see, you have a direct sight of the fingers, and the airport is in front of us. That is the platform where the airliners are parked close to the fingers, and we move to the left side, which is what we are doing right now, to park the aircraft. Okay, we will stop later on the engines, and you will be able to get out from the aircraft. Okay, so basically we have concluded our flight. This was a VOR DME approach, and many people don't know that an aircraft like this one is not so expensive. You see many videos from rich people purchasing Ferraris, Porsches, Lamborghinis and all that. By the way, we will stop all the buttons in our autopilot because we don't need them anymore. And you see many people doing that, purchasing extremely expensive cars, okay? And for the half of a price of one of those cars, you can get your own aircraft. And even with the money you will get, because a Rolls Royce, for example, a Bentley or cars like that will cost a lot. For the half of the price of one of those cars, you can get your aircraft and also the necessary training to fly it, and guess the sights we can experience with our own aircraft. Imagine you want to travel from a city to other city and you have to experience a traffic jam and all that. This is absolute freedom, okay? You on the sky, that is all. You on the sky, that is absolutely beautiful, okay? Really absolutely beautiful. I think many people are purchasing extremely expensive cars. I won't tell you that those cars are not beautiful and they cannot enjoy them, but seriously, many of those people should consider to own their aircraft as well, okay, because with their own aircraft they can experience a lot of freedom. Okay, so I will park it here. I won't put it in the end of the line because I want a bit of a space if someone have to check the engine or something like that. I will press the parking brake, okay, because I want to put the parking brakes because of course you will need to get out from the aircraft and I have to be sure this is not moving anymore, okay. And right now I will shut down the engine, so I will move the magneto switch to the off position, and also I will cut all the electricity inside the aircraft, okay. So you will see how the engine shut down, okay. So right now I will put the magneto, okay, as I told you, in the off position, okay, and listen how the engine is dying, okay. And right now what we will do is place everything off, is to put everything off. I will observe the alarms we're getting there, but don't worry about that. That is normal because it's a part of the shutting down process, okay. I am turning off the GPS. I will cut all the electricity inside the aircraft, so basically I will put all the avionics also off, so I will put the aircraft dead as it was before, okay. Also the magneto switch is off, as I said. We'll put off all the lights, okay, so all the lights will be off, okay, and the avionic master also off. So basically this aircraft is right now dead, and I did what I promised you. What I promised is to depart from Madrid Barajas, from a place full of cars, pollution, and everything. If you open the door, please, and you are so kind to get out of the aircraft, I will be grateful. Thank you. And yes, I did what I promised you. That is departing from Madrid to Ibiza. And as you may see, the flight was very easy to do. It's not complicated at all. And I wanted with this flight to clarify many concepts that people should know about what is a VOR, or how you should proceed with the VOR DME approach, which is very important also. By the way, the red zone in the wind is the part in which you must walk, okay. Please don't walk on the black side because we can have a problem, okay. I don't want you to destroy me the flaps or the ailerons, okay. So please walk in the red line, okay. And now you can go to the hotel, you can take a bath, you can order some food, you can have rest, and then you can have a lot of fun in Ibiza, okay. And if you're in the United States, I really invite you to come here to Ibiza because it's a very beautiful place. I'm not from Ibiza, I'm living in south Spain, Andalusia, by the way, but Ibiza is a very magic place that is attracting many people all the time. So, well, we have traffic behind us, if you see that, but we can say we have concluded our flight, okay. And I hope you have enjoyed this video tutorial as much I enjoyed to fly with you, okay. And we will be doing more video tutorials about departures, about many other different topics that I find are interesting. And right now I want to say goodbye, okay, and I hope we have the possibility to fly with you very soon, okay. So I hope you enjoyed the video, and bye bye.